So what? You guys can't hear the the video? I'm choking and dying right now. I gotta go on mute. Hello, hello, hello. What ho? Welcome back to another exciting adventure. Exciting and new. Come aboard. Alright, let me just try to get the shenanigans all lined up. This is just crazy. It's crazy. Can you guys hear me? Mic check, 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 check. Mic check for me, please. Confirm. Oh, yeah, for you. That's okay. We got a nice little, I'm just gonna put the link out. Let's just see what happens. Let's get this party started. Just click the link and join. And mind, you can hear me breathing? Oh, yuck. Yeah, shout out to Eyes to See, Danielle. She should be joining us, and maybe she can talk us through a little bit of her dome musings. I hear somebody, Derek O'Hara. You got to turn off your watch page, Derek, or mute your YouTube page.
Oh, yeah, gotcha. I've had to put you on a TV in the background on YouTube so I could actually see it at the same time.
I'm sorry.
YouTube is probably 30 seconds behind, so no big deal.
Sorry for that cough into the mic, guys. Yeah, Flat Earth Data, sure. Click the Hangout above, and we'll just have a menagerie of cornucopia today. It'll be fun. A menagerie of cornucopia. Thanks everybody for showing up. And yeah, I'm just gonna try to pull up. Well, I think it's awesome footage. And it was so funny when I was catching it because I had no idea what I was seeing. And I was like, I'm looking through the viewfinder and I'm thinking, what am I looking at right now? This is absolutely bizarre. And it's on the Chesapeake. Alright, hold on. Oh no, that was later. But I can play that for a little bit while I'm talking, because that was kind of cool too. I'll play this to distract the masses. Alright, I think that should be muted for me. Can you guys hear the water in the video?
I can't.
You cannot?
But I'm about 20 seconds behind.
Okay, well, let it catch up.
Oh, I hear it now.
Okay. All right, so just enjoy the waterfowl there while I try to find my file that I was looking for. And let's see. This was yesterday. I'm going to go on mute because I'm going to be talking to myself. Okay, am I back on? Can you hear me?
I can hear you on Hangouts.
Okay, yeah. All right, well, I guess that's true. This is so, I mean, there's so many nuances to try to remember. I've got to, like, I'm flipping between this screen and that screen. I just snorted. I just,
Yeah, and I'm like I said, I'm about 20 or 30 seconds
I
behind you
just,
watching
I just snorted.
YouTube. So it just turned to the picture in Haverty Grace during the day with the doc.
Okay, all right, so I'm going to push play on that. And away we go.
Okay.
So the thing that I'm going to try to figure out if... Okay, I should have... yeah, see, that screws it up. That screws it up. Okay. Okay, anybody in the chat? I gotta push pause. I'm going crazy. I'm so stressed out. Okay, pause. In the chat, can you guys hear me? Have I, I've got my mic open on my Streamlabs, so that's telling me that I'm open, but I want to make sure that you guys hear me.
Okay, buddy. Is this a mic check? Mic check. Can you hear me fine? Awesome.
OMG. OMG. These hotkeys. Okay. I just want you guys to know, like, I really, really try to remember all the shenanigans that I have to do, and I have not watched a tutorial on these blessed hotkeys. So anyway, I just stopped right here because look at this nice American flag, right? We would have to go out and find out where this is and how high this flagpole is, right? You don't see it?
I see it,
Yeah. All right, so here we go. I think that this is it. This should have been from Friday, right before I went to go pick up my kids. All right, so I zip back. There's the red roof house right here. You know what? Oh, Derek, here. This is where I'm stupid. Okay, I'm gonna share my screen with you. That way you can watch what I'm watching real time. That. Yeah, that's why you're behind. I'm like, why is he behind? Because I haven't shared the screen. Well, that's my backdrop. Yeah, let me switch over again. All right, so here's the red roof house. So, okay, so you should stop watching YouTube right now because then you won't be delayed. Yep, gotcha. Okay. Flat Earth data, is that full zoom? I don't think so. Again, if I were letting this video play out, you would hear my commentary. When I started the video, it was just full optical zoom. So if you mean full optical zoom, then I would say yes, it's full optical zoom. Yeah. Okay. So for whatever reason, I go back over here to the red roof. I got some great red roofs today. A lot of good inferior miraging with a nice little aqua band, right? Okay, so look right here, guys. So right here we have the surface of the water, and this is where the surface of the water ends. This morning, I got a nice aqua band right here, an aqua band that led up to an inferior mirage, but the water line was dropped back, right? All of that stuff has to be taken into account and analyzed. Full zoom and lower to the ground will create an artificial horizon. Yeah, you've reminded me of that, Flat Earth data, and I appreciate that, and I will do my darndest to remember to get that going. All right, so watch here along the water line. I catch this image that I think is the top of a boat going across the surface of the water. And I can't see it very clearly through the viewfinder. I see something, I go back. Okay, here it is. You see that? I'm going to stop it. I'm going to stop it right there. Okay, right. So, right. So what I thought, because of what I've seen before, I thought that this was a fisherman, right? Okay, so here we go. Moving along pretty nice. Nice little clip. Zoom in, try to see if I can see something. Not really, it doesn't make it any better. What is this? What am I looking at? I'm saying to myself. What am I looking at? Wait for it. You gotta wait for it. Look at that. Look at that. Look at that. And thank you for the correct term, because I'm like windsurfer. It's not a windsurfer, but he's surfing and it's windy. But it's a kiteboarder, yeah. Okay, now look, watch this. Look. Let's bag it up. Let's bag it up, yo. Watch right around here, right above the water line. Watch right there, and watch for the spray of his board. I think I just saw it. Right there.
Yeah, I keep seeing little splashes from it.
I'm going to try to stop it. Right Right here, you got this little mist. Right there. So Derek, I caught another barge coming in today. I should actually go out to my car because I left. There was two of them. You just see them do bread and butter. Did you see the second one go? The other one, yeah. Here it comes. Right there. I got Derek is very quiet. Oh, you know what? Maybe that's because I lowered the desktop audio. See, that's what...
I can try to speak up into the phone a little closer.
I don't think that's the issue because you're going to raise your voice in my ear. I think it's because I lowered my desktop audio because I didn't want the water playing right now. And I think that lowered your levels too, but I'm not real sure because I'm still not completely IT savvy on this. Let me stop this real quick and do a check on the audience. So I just elevated the desktop audio. Did that only elevate the water audio, or did it improve Derek as well? I couldn't hear Derek at all. You're good now. So we've got NASA, no actual science joining us. Hello? Oh, this is Flat Earth Data. Can you hear me, Flat Earth? I can hear you clicking. Flat Earth Data, give me a mic check there, bro. I'm going to kick you. I'm going to kick you so fast, man. You better speak up right now. Just kidding. I'm just kidding.
I can't. Can you hear me?
Yep.
Oh,
good.
Oh, I'm just
Gotcha.
trying to figure out my sound. It seems like Google Hangouts fucks with my sound card. I can't run it through my device, so it's going through the internal.
Okay, yeah. I was just messing around. So anyway, Derek, I caught this barge this morning, and it was absolute gold. Absolute gold.
Awesome.
So there were a lot of sailboats that were crossing along its path and in front of it, and there was a fantastic inferior mirage. So a lot of good stuff just to look at and to contrast.
Yeah, there were two huge shipping freighters going out past the Chesapeake Bay Bridge yesterday when I got out to North Point State Park. But the viewing conditions were horrible. It wasn't hazy, but the miraging was really bad, so I couldn't see them for long. And when I did, it was really wavy. It was when you would think that it was 90 degrees.
Chris, or no, Travis. Flat Earth Data, you're Travis, right? I don't know if you can hear me. Can you go on mute while you're clicking around, Biddy? He can't hear me. Nobody listens to me. Anyway.
I'll mute myself while I'm trying to figure that out.
Okay, thank you. So, yeah, so this is just, I think, just awesome. Awesome footage.
Yeah, that's really cool, and it looks like a blast. I want to do it.
So, yeah, when I was in California, there was a spot where it only seemed... Ooh, that was a good shot.
Jumped.
There was a spot in California where I shoot where it seemed like all of the kiteboarders would go. Look at that.
He pulls down to
Yeah. Yeah, so think, honestly, think about this, right? Because wherever that water line is, he's distant from that.
Sure.
And yet we're getting the spray. We're getting the spray of his wakeboard.
Which can't be too high.
Right. So it's below the horizon, so quote unquote, right? Booyah! All right, let me do this real quick. Danielle, anybody out there, how is the audio for the video? Am I competing with the audio for the video, please? Anyway, there might be a point where Flat Earth or anybody else is talking or sharing, and I'm going to run out to the car to go get my SD card for that footage from this morning.
Oh, awesome.
It was really, really good. Where'd he go? Watch this. Watch it. He just wait. Where'd he go? There he's right there. There he is. Where'd he go?
It's interesting. When he jumped,
Where is he? Derek, where is he? Oh, there he is.
Look, what's interesting is
Where'd he go?
It looks like you're seeing his legs almost down to the water.
Yeah.
But you're
not. You're
actually
not
seeing the mirage of his upper body.
Yeah.
Because you notice it when he jumps, and then all of a sudden you see the mirage line.
Yeah.
That happens with so many things when people think they're seeing them off in the distance. They think they're seeing the bottom of something, but they're not.
Look at those. Look at these birds taking off from there. I'm gonna back it up again. Watch these birds off to the left. It's like he comes into their proximity, like, oh, get out of here.
Yeah. I saw a great lecture on perspective by Brian Mullins. I was watching it yesterday, and it was really awesome. Learning. There's so much to learn about perspective.
I know, man. I know. It's absolutely a new school. Look at this. Look at this wake spray. Look at that spray right there. So let's go back and look at that, right? Let's go back and bring up your point on the inferior mirage. So
people would assume that's his legs below your arrow, but it's not.
Right, but then what we have to understand is that the inferior mirage has swallowed up this entire visual right here of what's what's physical, right?
Exactly.
And so what we need to understand then is that even right here,
there are waves.
Yeah.
Really.
Yeah, but they are below the angle, and then when his spray comes up, that is breaching. That's breaching that angle that we can see. All right, let me jump into chat and say hi to hi to people real quick. Adam's here and Danielle is here. Constance and Flat Earth Data is getting his shenanigans ready for a little presentation. Danielle, obviously you are free to join. I will put the link in the chat. Mark Doxy, if you're still here, hello. You're out doing some DoorDash. And let's see who else. Alexander Lightwater. Yeah, just respond to whatever I emailed you. I'm not even really sure what it was anymore, but yeah, let's keep talking. And Vahid M, thanks for being here. James Rohrbach, thanks for being here. 5 out of 5, appreciate it. Yeah, you guys share this stuff. Let's get as many people seeing this as possible, so that we can have people smarter than myself thinking through. Trish Blythe, or is it? Yeah, I'm not gonna butcher it. I'm gonna say Blythe. Okay. There she is.
There she is.
Miss America.
Yeah.
All right. So thanks for joining, Danielle.
Thank you for having me.
Everybody say hello to Danielle. Get a mic check on Danielle. Anybody out there? Yeah, I guess it should be working if Derek can be heard and whatnot. I can hear you guys fine, so.
Hey, Danielle.
Hey. Nice to meet you.
You too.
If I haven't already.
This is the first time I've been on Hangouts, so.
Oh, okay. Well, probably then.
Yeah.
All right, so I'm leaving those guys behind. I'm going to go see what's out here farther out on the bay. This was Friday afternoon, like 3:30, because I wanted to go shoot before I went and picked up my kids from school. And
so when did we go out on? Like 12:30?
Yeah.
So about 3 hours later. Okay.
Yeah. Yeah, so that we can do that. Let's just do that real quick. I'm going to drop out of here. I'm going to go back to that file. I don't think that I'm going to bring up anything unless a baller shows up and wants to discuss my my cliffs of insanity. Did you watch that video?
What's that one?
I did a live stream yesterday morning at 6 o'clock for about 40 odd minutes. and I presented some.
Definitely wasn't up for that one.
No,
But,
I was not awake for that.
Oh, you haven't seen that yet. We might either delve into it today then, in a short abbreviated version, or you'll definitely.
I was watching your karaoke earlier from yesterday.
Yeah, where I was driving through the 476 corridor, and it was just absolutely horrible connections, I guess.
Yeah, you called it buffering Pennsylvania. Huh?
Yeah, Buffering County.
Yeah.
All right, so this is.
The road's really terrible still in Pennsylvania because I haven't been there for a few years, and it was like the tolls are $30 freaking dollars, but it's the worst highways I've ever seen.
For sure, and they're always working on it. Yeah, for sure. All right, so these are just some clips. This is a video. This is a 1.5 minutes long.
So I was hoping that the miraging would go down as it approached dusk yesterday, but it actually did the opposite. The mirage line was going up the longer I waited, so I only stayed there for about an hour and a half.
Yeah, yesterday was. I think it was yesterday. Was it yesterday?
It was really beautiful outside, but
yeah. It was the last couple days, one of the last 2 days, and it might have been yesterday when it was absolutely cold. And I have found, because if you remember when we went out in March and did our mirror flash or our camera flash, the temperature was moderate. It wasn't hot. It was a March day. It was not.
It wasn't too bad.
And it was the worst visibility I'd ever had. Ever. I was absolutely blown away because it was such a nice day. Same thing with yesterday.
Yeah.
Same thing with yesterday because it was so cool and crisp and there was a wind, right? Okay.
Yeah.
Do you guys know what the ballers say about wind and visibility?
Oh my god, I don't want to know.
Supposed to make it better.
It's supposed to make it better. It is absolutely not true.
Well, it takes the humidity away, which is nice. But I think especially over the water, I don't know if maybe it's the waves, it's making more moisture in the atmosphere, but it really makes for a hazy look as you're observing it over distance.
Yeah. So again, that kind of detail, those kind of variables, this is a full-time endeavor.
Yeah,
absolutely.
So many variables.
Absolutely.
You really have to go there weekly over the course of a year, keeping track of humidity, air pressure, and then you might have some kind of idea.
All right, so let me do this. I'm going to pull up a contrast right here with this image because if you remember, we have some inferior miraging going in this same location, and it's not here right now. So let me bring this up real quick for a contrast.
Now, do you have the footage on your computer from last Sunday when you were catching the mirror flashes from the lighthouse?
Yeah, I can bring that up. I haven't looked at that yet, so we can even review that.
Just since we're both here, I figure
Yeah,
we could
sure.
lend both.
All right, I'm going to try to figure out how can I shrink this. I'm double clicking the.
So I can steal my 5 seconds of fame on your channel, Travis.
Yeah. You're a glory hound. You're just riding on my coattails.
I am. You do all the hard work. I just come along for the ride.
Okay, so let's see if we can get something that's somewhat of a semblance of.
I'm hoping that some of the people who are trying to insist to me, one person in particular, that there is no ether, would show up.
Yeah, I mean, ultimately, I'm not making a metaphysical, scientific declaration about ether. I've made that clear.
Right, well, there's something. I mean, there's something doing that.
Well, yeah, but not only that, though, Danielle. My qualification is look up Wikipedia, and it will tell you the very first meaning, the denotation, right? Not a connotation, not something to be associated with ether, but the meaning of ether is air.
Right.
That's all it means. So when we talk about the whole metaphysical thing, where we cross over into the scientific realm, that is where we are getting into whether or not it is. Why won't this cooperate with me? My point here is, see how this is. If I shrink this down, why? Oh, I think I should use my Okay, well, I'm just going to do this. Okay, so we have these two images, right? The same exact location, different zooms, right? It's different zooms. So right here, these two trees are right here. Yeah. Okay. And then this cape is right here behind this boat. But notice what my point is. My point is that we don't have an inferior mirage like we do right here. Right? Let me see if I can go back.
And that's a high mirage line on the left. Because, what was it? Well, Sunday morning we could see down onto the property. That's beneath those two trees. But yesterday we couldn't.
Yeah, this is, okay, here, this is less than full zoom. Okay, so I'm not even extended to the full optical zoom. And this is what I said to you the other day, Derek, is that there are times when I have more in my field of view on my viewfinder than I do on other days. And,
yep.
You know, that's
magnified.
That's due to magnification. So what we'll do right here, let's do this. Let's see what this file information is. That's even less. So that's 152. So that's not zoomed in as far. Let me see if I can bring up a contrast with anything. That's 152. See, this is this is why I started doing this. I just wanted to like go through this stuff and let people hang out and watch if they wanted to watch.
Sure.
And I'm just kind of working through the shenanigans of what I'm seeing. But this is 428. Let's do a 428. And 428, regardless, again, I was told by Alan Evans on Jose's channel that 428 is not an accurate representation of what the P900 measures. So I said to him, well, then how am I supposed to know? If I open up the data, if I take these pictures, then go back and open up the data and see what it tells me, and you're telling me it's false, what the hell good is that? You know what I mean?
Yeah, exactly.
I mean, that does absolutely no good whatsoever. All right, so this is 152.
Well, at least with...
Here's 428. Okay, so we have two 428s right now to contrast. Go ahead, Derek.
I was just going to say that I think yours were very comparable to mine with the telescope, and that had no digital enhancement or interpretation. So I don't know what exactly he expects the P900 to change about it.
Yeah. See, the difficulty here and that I find is lining up the same shot. So you can see right here at the very end of the cape is right here.
Yep.
And then you've got this tree line. You've got these two. You've got the two twins right here, which are going to be off camera here.
Sure.
There, oh, here we go. Here we go.
Yeah, there you go. Screwed over. Perfect.
Okay. No. I just changed to the next. I just went to the next file. Okay. This is the same. Here it is. This is the same. So both of these are the same zoom, and this is going to be an episode where I would introduce my "Can you spot the difference?" Right?
Yeah.
I would say that there's
a slight difference. The one on the left appears to be somewhat smaller.
I was going to say that, yeah.
Because it almost more dense, but that could be because of the way it's in the shadow compared to the light of the water. I don't know. Who knows? That's the thing. There's so many different variables to consider.
All right, I'm going to jump over to the chat real quick and just say hi to if everybody else joined up.
Hey, Travis.
Yeah.
Can you hear me?
Yeah.
Hey, can I present my screen and show you guys some stuff that I've done? It's exactly what you guys are doing now.
You ready for it?
Yeah, it's just quite easy.
And your name is Travis too, right?
No,
Okay.
just call me Flat Earth Dad. That's
okay.
fine.
Okay, I couldn't remember. I thought it was Travis.
No.
Okay, so if you share your screen, do I have to stop sharing mine?
I believe you do, yeah.
Okay, so I'm going to stop sharing mine, and away we go.
So remember I was asking you next time you're out there, bring the camera down to the ground as much as you can and zoom in full max, and you'll create an artificial horizon.
Okay, now I don't think that you've started sharing because I don't see anything.
No, I haven't yet. I haven't yet.
Got
I'm
it.
about to,
Got
I'm
it.
about
Okay.
to share there.
Okay.
So also as well, this is a program. It's free. It's a free editing coloring program for professionals. It's called DaVinci Resolve. Anyway, that's what I'm using here is DaVinci Resolve. Can you guys see this image here? I'm going to blow it up for you.
We can.
Oops, sorry. Let me just see what I can do for blowing it up.
And Flat Earth, just to let you know, Derek is here. Danielle is here.
Hello, people. How are you?
Hello, other person.
So this might not be the best example because I wanted to blow it up. So maybe I might have to go back and just reconfigure my computer here because you guys can't really see that small image, can you, very well?
Well, you mean the proximate image?
Yeah, the image here. You can barely see it, right? Or you can see it at
looks
least.
like
You get the idea.
Yeah, it looks like 3 buoys.
Okay, so this is maybe I'd have to go look at the map, but if I was to guesstimate anyway, this is about 50 yards from the observer. Okay, these buoys I'm at a lake. The lake is no bigger than not even 3 miles across. This is just about 50 yards from the observer standing on the shore, and the camera is right about 2 inches above the ground. What I've done here is I've created an artificial horizon. You guys can see this water line, correct? Right?
Yes.
Yep. Okay.
Okay. So now anybody who's going to study light and angles are going to realize this is a result of that, in combination with, of course, the atmosphere. What's happening to the water? The water is dissipating. It's being heated up, and it's evaporating, and it's causing this ether band that you like to describe it as. Well, what I know, and my hypothesis is when you take angles of light, they're straight. Okay, for the most part, angles of light are going to hit you straight. Okay, very extreme what's the word I'm looking for? Very extreme.
Extenuating circumstances?
Yeah, thank you. Extenuating circumstances will, bend light. We know that. But in our practical daily lives, we have what's called Snell's law, which is basically, let me see if I can bring it here on the screen. I'm sure you guys are familiar with Snell's law. Just drag it over here.
I've looked at it briefly, yeah.
So this is basically what you're watching, right?
This is basically a representation of a pencil in water.
Essentially what it is it's the ray of light being affected by the exchange of mediums. It's going from one exchange to another, and therefore it's causing this angle, and then you get for this refraction. The point of this video, gentlemen, is I wanted to simulate this horizon because the idea is that light doesn't change. It doesn't matter if it's 100 yards or 5 miles or 20 miles. Light at this scale and in this manner will remain the angles of an incident will remain straight. So my theory is if I can mimic the same results on small scale at 50 yards on a flat butt of water that emulate circular sphere images, then we can correlate that the rays of light don't change on small scale to big scale because they match observation.
Good. Okay.
So what I've done here is I have a remote control boat. So there you go. There's I am. I'm on the shore. There's the distance. I wish I could blow the image up better for you. So what I did is I created an artificial horizon. It's kind of shaky until I settle it up. Anyway, what I've done is I've taken my remote control boat and I've driven it past this buoy.
Very clever.
So just to simulate. No, hold on. Is it coming up here?
So like an RC boat, like it was what, like 30,
exactly. So what
inches?
I'm doing is I'm emulating reality in large scale, reducing it, because if mathematics is going to translate, right? If it's a constant, then it's going to be either scalable, a small scale, or a large scale. Now, my computer's freezing here. I guess DaVinci Resolve's not digging it right now.
Okay, so give a second while it's trying to catch up with itself. Let me ask you a question real quick, Flat Earth. Where was it? Oh. So
I'm not even done yet.
I know. I just have a question of clarification for you to kind of flesh out a little bit. Okay. So you've made the statement that this light is coming to us straight on.
Okay. So my understanding of Snell's law and refraction is the angles of incident reach the eye in straight beams. Okay. Everything goes from a light source reflected off that. The light source hits the object goes back to our eye. That is all preceded by straight lines of light. Correct?
It makes sense to me. I understand what you're saying. Yeah.
Okay. So I'm hypothesizing that angles of light can be demonstrated in small scale as it can be in large scale. Now, what I can do is I can destroy, in the same observation we're doing here, I can destroy the argument that the Earth curves at 3 miles and back it up with observational, repeatable, demonstratable experiments you can do, or observations you want to call them, not experiments, that substantiate that angles of incident, which is angles of light, over a period of distance will become too acute to resolve, and therefore get a form of diffraction. Which in the sense is a horizon line is a form of diffraction, which is the angle of incident becoming too acute to resolve, because our eye is a lens and our eyeball has an aperture. That aperture has a constant of 1.22. So you can take sine equals 1.22 lambda over of diameter, which is the diameter of a human eye is an average of 4 millimeters. You can take the 500 nanometers, or not nanometers, but how do we see? What's it called? What we see? The UV spectrum we're in.
That's out of my ballpark.
Just visible light.
It's visible light, but it's 400, 500. It's between 400 to 700 or something is visible light that we humans can see with our eye. Anyway, so what I've done is I've, under the impression that the Earth is flat plane and the light works this way, I've decided to apply that hypothesis at small scale over a shorter distance, and I achieve relatively the same effect. Now, see the boat here? Here's my electronic boat. See that?
Okay.
Do you see that little yellow thing there?
Yep.
Now, unfortunately for my experiment, because my boat can only go so far, I wasn't able to keep continuously going forward, knowing that if I went forward, because it's less than a 3 mile, there's no curve on this lake whatsoever, that I can actually make that boat disappear beyond that refraction point.
Yes.
Now, that was the intentional of the experiment. Now, what I did...
Can I ask you a question or two?
Yeah.
What's your viewer height?
So this is about 2 inches, maybe an inch off the ground, 2 inches. I'm trying to emulate the horizon. I'm trying to get the artificial horizon light, because my hypothesis is that the angles of light become too acute to resolve, causing a diffraction point. And for the human observer, average height 6 feet, mathematically, it works out to be 2.99 miles away where the horizon is. So if you take that, I'm just going to share something here. If you take that and apply that concept, I'm just going to show you something here. Now, what I've done, and anybody can do this, sorry for using the Google Earth, but it's the only resource that I have to give my point.
It's a helpful tool.
So see this point here? Okay, so this is me, the observer. I'm standing 6 feet on the shore right here. You can see that, correct?
Yep.
Yeah.
Okay, I have a 2.99 mile radius from the observer of my observation, which is this circle here. Okay?
Okay.
Now, what modern man is claiming that an observer at this point will witness a boat pass this red line, which is the 2.99 mile due to diffraction over the horizon.
Flat Earth.
It will.
I just want to clarify for the listeners, just in case someone isn't up to speed with how you're talking. You are 6 feet on the shore, and your visibility in front of you, as well as in a 360 degree, is around 3 miles before the horizon will begin to fall away from you.
That's absolutely correct.
Okay.
And if you want to get a great perspective of what that means grown adults are claiming physical curvature is passing this radius. Now look at Earth. They're claiming physical curvature.
Yeah. Well,
over
it would
that
need to
radius.
It would
right?
need to be at the size they claim.
They're claiming 6 feet on the shore, and observers right here, that boats go down curvature past this point, sir. And all you have to do is zoom up to debunk that. Look at that. They're claiming that observer right now in real time, if we were above that observer, just directly 90 degree zenith.
Yeah. This is the top of the world right now. We're at the
That's right.
We're at the North Pole.
We're not looking towards the observer. We're 90 degree zenith. Yeah. That observer in real time is claiming that boats are passing this radius here due to curvature, when you know right away, look at the Earth, there's no curvature at that point. There's no way there's curvature at that point. So the idea
Well, there would have to be some curvature.
No, there's no curvature, and I will show you why.
No, I'm saying according to them, there would have
No, I will show you why. There's no curvature, and I will show you something you can do yourself to prove. Now, what I've done is I
know there's no curvature.
Awesome. So you can show all your friends, and you can simulate diffraction. I'll give you an easy experiment to simulate diffraction. Take half your lens, take the bottom half of your lens and cover it with tape. So the bottom half is 50%. Set the camera level, best to your ability level. Put an object in front of it like a person. Get that person to walk away. Due to distance, that object will reduce in angular size and appear to move downward towards the middle. This is something. This is
Of
something.
course, that's how perspective works. Yes.
Exactly. So I have an observation you can do. That anybody can do, and I'm sure you've seen it, where you can simulate the obstruction due to angle of incident being too acute to resolve. In other words, what you're doing is you're claiming that the angle of incident is too acute to resolve, so it's creating an obstruction that objects move past behind, and it appears to move downward. Okay, so I have a video here, and anybody can try. And what I've done is I've done what I've suggested, which is to cut off 50% of the camera, creating the artificial obstruction at 2.99 miles because of the human eye, ramps things upward. You can see the object reduce in angular size due to distance, and because of that fact, appear to move downward, thereby alluding that there's some type of curve. But in reality, in real time, there is no curvature past this radius. The boat just keeps moving straight forward. But because our eye ramps things up into the center of frame, and you know what? Here, go Google the definition of horizon. It says the apparent junction between the sky and the ground. That's at 2.99 miles, guys. So it's not physical curvature. It's 100% optical. That's it. Thanks, Travis, for letting me show that.
I have a mouthful of peanut butter and jelly sandwich, so you guys talk.
So yeah, and I've seen with my own observations the horizon far past, the less than 3 miles. So I've seen horizon at 5 miles and 6 miles. So there's obviously no way to account for it because
You're missing the point, sir. You're missing the point. The point is the observer on the ground is claiming that at 2.99 miles, a boat 20 feet tall, 8 miles later, will be obscured by about 16 feet. Okay?
Well, who was
you can
claiming?
see that's the mathematics of the globe. I have blue marble science.
So
hold on, stop. I have blue marble science admitting it. I have Rumpus admitting it.
So
I have Rumpus admit it. I have Critical Think admit it. Basically, what I've done is I've used their own math. I've documented all this. Now I'm coming forward with more material to see the responses I get from presenting it. So thank you for your response. But
yeah, I'm trying to clarify.
Yeah, but logically, you can see at this radius point from the observer, it's literally impossible to have boats physically go down curvature. You can see it's illogical, impossible, irrational, and it doesn't even make sense. And I can present it right here, clear as day, and then back it up with an observable, repeatable, demonstratable observation that anybody can do.
Yeah, Flat Earth. I just want to stand up for Derek. He's not challenging anything that you're saying. I think that he's just trying to express what you've said in his experience as well. So I don't want you to feel like you have any enemies on the board right now or on the panel because we're all on the same team. But
yeah, exactly.
Yeah.
I agree.
Yeah.
Can I ask for a clarification?
In a second, real quick. Yeah, I just wanted to say hello to Mark Doxey. Hello from across the pond, Mark.
Hiya, folks. Can you hear me okay?
Yeah. Are you on a cell phone or something? It sounds a little bit like you're in a closet, but I think
Yeah, I'm on hands-free. Can you hear me?
Come on, come out of the closet. Come on.
We can hear you. It's just a little quiet.
Okay. Well, listen. When you said that the horizon is 3 miles away across an ocean, is that for somebody who is standing up 6 foot, or if they're swimming in the water and the horizon?
So if you go online right now, you can use Bizlin, you can use McWest, you can use mathcentral.org, you can use many calculators. The calculation for an observer 6 feet high, the optical horizon line is about 2.99 miles away. This is what the definition of Wikipedia says. It's the apparent junction between the ground and the sky. Not once does it mention your eyesight is the cause.
No, I just, if I'm going to use what you're saying, and I think it's fabulous, I don't want somebody to come back to me and say that it's 3 miles when you're actually swimming in the water. But it's 6 foot high. That the horizon should appear on the globe 3 miles away.
That is what they claim, not I.
Yeah.
That is what they
Yeah,
claim.
that's fine. That's no problem. Good man. Thank you.
All right, Flat Earth. Listen, man. I am absolutely looking forward to however and whenever you're able to present your studies. I'm impressed with your diligence and your passion. So, take it from me. You've got a number one fan. So I appreciate it. Anytime you got something, if you want to share it, just let me know and we'll set up something. Is there anything else, or was that the presentation that you wanted?
Well, I do have an idea to toss just to get some feedback.
Okay, well, let's table that then real quick if you've got the time, and let Danielle. Are you ready, Danielle?
I'm not sure. Yeah, I'm not sure how to do the screen sharing thing. You're gonna have to tell me which buttons to click, but I've got everything.
Okay, do you see the Hangouts window where we are all represented with our icons or cameras?
Yeah.
Okay, so at the very top, you've got 3 vertical buttons.
Yeah.
Click that, and you'll see the first selection is share screen.
Okay.
So, Flat Earth Data, if you could unshare yours, and then Daniel will have the ability to go at it, I think.
Yeah, it's all good.
Thank you, sir. You're on, Danielle.
Okay. So
We're back.
I think it was in about, are you guys seeing anything? Because I can see Derek.
No, yeah,
Yes.
I didn't think about this. We still have your camera. So, did
Okay.
you, okay, so go up again, because I think I did this by accident. Go up again and do your share screen, right?
Yeah. Yeah, I got that. I think, okay, I didn't click the,
You have to choose the window that you want to share and then confirm it. You should have 2 selections.
Okay,
There you go.
yeah, I got it.
Okay. All right.
Okay. I was in Michigan, in South Haven, and I'm going to show you here on Google Earth Pro. I was at this pier, and I made a video where most of everything you can see in it, I'm going along this little shore here, and then I get really good shots of the Palisades power plant right here, and that's, let's see, this line, 5 point something miles. How do I? Oh, stop doing that. How do I tell it to tell me how long that line is?
You can use measure if you click on one point of it.
Yeah,
If you already have it saved, go
Yeah, I
to the
do.
then go to where it's saved on your left menu selection. Right click it, and then show a profile there. Show elevation profile. Is that what you
Okay.
wanted?
Yeah. Okay, so here's the pier, and then here's the power plant, and it's 5.63 miles. Okay. And then in the video, you can see all of this, the power plant really clearly, but then you have some lights. I kind of pan over and you see, like, buildings, and it gets, obviously the view gets all really obscured. And then down here where it's, this is another pier in Benton Harbor or St. Joseph. I can see the lights flashing at the end of this.
Wow.
And
How far is that?
let's see. That is 22.4 miles.
Incredible.
And unless I mean, there's nothing else along. I used to live here, so I'm pretty familiar with, this stuff, all this area. And I mean, there's nothing else large sticking out into the water that has big flashing lights on it. There's no other giant thing here. This is all, woods and just a few residential areas, a campground, nothing like that. So let's see, let me get this video. Go and yeah, do that really awesome talking thing you do, Travis, for a couple seconds till I find the video, because I just edited it and now it's not like.
Well, that's like a lot of pressure.
Well, can I just say something? I want to just say how grateful I am to all the people out here that are doing their own observations. I mean,
Okay.
look how many there are of us that are going out and we're making our own observations to test things for ourselves. I think that's really cool.
You can see all my funny pictures. That's stuff I was getting ready for a movie night. Okay.
Yeah. So shout out to Ice to see for her movie nights, and just plug your Saturday night movie fest. We watched something last night. What was it?
The Things to Come, the H.G. Wells movie from 1936. That's what we watched last night. And I typically, it's always something, public domain. I've typically been doing sci-fi. I'm really interested in going back and looking at a lot of the really old movies and seeing how much, predictive programming is
Yeah.
placed in there. And it's not any less at all. It's exactly the same amount. And
I used to think that those movies and TV shows were almost prophetic in what they predicted, but now I realize that it was just script the entire time that they were
Yeah.
following.
I mean, exactly, and it's the same narrative, the same. I mean, even last night, that was 1936, and we're seeing. You could almost read to me like the Book of Revelation along with it, because it had like, all this war, rumors of war, and it had like the post-apocalyptic thing going on, and then there was this. Toward the end, it was like a dystopia or utopia, whatever. And nobody was sick. The guy was talking about how they used to.
That would be Utopia.
Yeah.
Yeah. Well, I'm not. I guess I think it was. Yeah, I mean, it was a utopia to them, but it still was like a false.
Oh, sure. Yeah. That would almost be like living in a world where no one got angry, no one got hurt feelings. I mean, that's
like a Scientologist.
Yeah. That would be dystopic, totally, because we're so dynamic, we're so emotional. I mean,
that reminds me of that movie Equilibrium.
Yeah, I haven't seen that, but I did look into it when I was doing one, I think last week. I was looking at a lot of.
They suppress everyone's emotions.
Yeah.
Peace.
Yeah.
But then you lose humanity.
Can you guys see my video thing I got going on here?
Yeah.
Okay. So this is the South Haven Pier, South Haven, Michigan. And from, let's see, my little thing down here, there we go. I'm going to pull it back over here a little bit so you can see the beginning. Okay. It's not a super long video, but I'm panning out there, and then you can't see the smoke in the background. Let me pause that. I guess it's Steam, the Cloud Maker, whatever. I hate Windows Media Player for that. You can't like go back and. So right there, that's the power plant.
Okay.
And that's 5 miles. It doesn't even really look like it.
Yeah.
And I'm not zoomed out at all here. And so this would be, pretty similar to what your view from your eyeballs would look like.
Right.
And it's that right there, that chunk of land, it's so much longer than it appears, and it kind of curves in. I'm facing south right here. It kind of curves in and then comes back out, and that's why I'm pretty sure that other flashing light that you're going to see, I'm just going to let it roll for a second. So here I'm zooming in, and then you can really see the power plant, and that is 5.6 miles away. And I got down over here. You can kind of see where like the
mirage line.
Yeah, it's pretty clear there.
Yep.
Yeah.
Yep.
And this goes. I went on Google Earth, and I was actually looking at the the whole street view thing, and you can really see up to all of this, and you can even see like these hills and the trees, and it's like you're standing right there.
Are you saying, okay, so when you talk about that from Google Earth, are you saying from your location right now, when you look on Google Earth, you have no inferior miraging, you see straight to the shore?
In some places. Now, not from where I'm at all the way to here, but I'm not sure how far I was, maybe a mile, where I could see let's see. I'm on a different computer than I saved everything I had before because that one kept crashing. And so let me see if I can get this going on down here. I was actually traveling along my line here to see what kind of view I could get, and turning around to the shore. Let's see. Now, this isn't going to be the same as, yeah, it's not going to work the same as it did when I was on the regular Google Earth setup. Yeah, that's funky. Okay. I'll have to go back to the other Google Earth. I don't want to like make a bunch of dead airtime, but okay. So I'll keep going with the video.
Let me back up real quick. Do a 10-second backup, if you can.
Which one is it?
Well, I don't use media player, so
Yeah, I'm gonna open it. I'm gonna open it in Photos.
Yeah, Photos has a 10-second, 30-second alternate.
I always use the media player for the slow-mo, and I guess just kind of by default.
Yeah, I've been having trouble with VLC lately. It buffers like crazy.
I haven't used that in so long.
Best video player ever.
Jose J.G. Gonzalez, welcome to the panel. Welcome to the show, my friend.
All right, tell me.
It's nothing to fear. Flip Flop is here.
All right.
Hi, Jose.
Was it before this that you wanted me to pause?
No, yeah. Go back like 10 seconds. So yeah, go back another 10. Okay, so for me, okay, no. Okay, don't
right there.
Right there. Yeah.
Right there.
Yeah.
Okay.
Yeah, just right there. Just a little bit to the left, a little bit. No. Yeah, right there. Okay, so you can't see my mouse.
No.
No, you can't see my mouse.
Can I share this to you on Drive so you can pick it apart however you like?
No, not really. So just if you go to if the audience looks just simply to the left part of the screen, and you've got those two bushes on the right, and then scoot over until you've got a red mirrored mirage, like you've got a line.
This thing?
No, keep going to the left, Danielle. I see your mouse now. Keep going right there.
Yeah.
Okay. So we've got a mirror right there. So here's my ether band, my aqua band supposition. That is where your mouse is right now at that water line to that physical location of the land. We should be able to see, but we cannot because of the inferior mirage.
Right.
Not only that, though, the line on the water where your cursor is at to the physical land immediately behind it has a real distance.
Right.
Right? And that's all part of this discussion. So now go over to the power plant. Right there. Right there.
Yeah.
You've got those two lights mirrored on each other. Right in the middle.
Yeah.
Over right there. Boom, boom. Right? Same thing there. So you've got the same water line, and then you've got distance. To me, that's so abstract, but I'm absolutely fascinated by the abstraction. So I'm just totally geeking out on that. But okay, so go ahead. Keep going.
Oh, just wait till you see.
Oh, this wasn't the pièce de résistance?
Well, there you go. Now you can see the same light down here. And it's kind of the same view we just had, but still zoomed in. And so this hill here kind of blocks. I actually went to their website and I was looking at pictures where they've kind of changed a couple little things over here. And I was trying to figure out the exact, angle I was at, because I knew where I was at on the pier, but I wanted to see, how much I should have it obscured and all of it. I mean, I spent like an entire day picking this apart. And this right here, trying to figure out because there's a couple little towers there. And because I wanted to tell how much of the bottom I was actually looking at and how much of this, mirage was covering it up.
Do you mind if I jump in real quick?
Sure.
So right now, from Jose's channel, Barney Jose, has volunteered his time to crunch the numbers on distance and curvature with the images that I've given. And my position, and Danielle is talking about it a little bit right now. Where did you go, Danielle? You're moving around.
I'm just panning over.
Okay. So,
Hey guys, Travis, sorry to interrupt. You guys want to know some basic math so you can calculate?
Hit us with it. Hit us with it.
Okay, so if you ever want to know what a hidden drop is, really quick, just really rough practices. 8 times 2 inches. Okay, if you want to know the drop of something, so take the distance of any object and times it by 2 inches and divide it by 12, and you'll get the foot per drop from section A, from point A to point. So let's say observers on the A, and then you have the middle point of the horizon line, and then the boat passing down. If you take 8 inches, or that's the miles. Sorry, take the miles times 2 inches. That's whatever it is. Then you get your math divided by 12, and you'll get your foot per drop. That's a quick, easy way to get your hidden. This is your hidden drop. Now, this is not the drop, because if you did the 8 inches, it would work out to be 42 feet instead of 16 feet.
I got you. I got you.
So, and listen, they want to tell you to the cows come home that the 8 inch per mile squared is a parabola. Listen, I have Rumpus on record telling me that it's accurate. I have Critical Think telling me on some record on it's accurate. I have Blue telling me on record it's accurate. They switch up their method between 100 miles to 1,000 miles. One Glober says, oh, it's only good for short distances up to 50 miles, and it fails. Listen, you can beat them with easy, quick calculations using that formula.
Repeat that again. Repeat the easy formula again, so I can revisit this and listen to it later. And that's zero feet observer height, right?
This is just no. There's no. Actually, wait. There is another quick way to add in the 6 feet, because I usually just use the approximate calculation. But
can I stop you real quick, Data? You're really loud in my mic, so if you could lower your
Sure. 1 second. Sorry.
There you go. That's better. Thank you.
Well, I just backed away from it.
Yeah, okay.
Okay. So anyway, just a quick calculation. It's the mile times 2 inches for quick hidden obstruction. Then you can go to 3 inches. So it's a little bit of finagling, but for quick basis you
Let
can
me
use
ask
2
a
inches.
question. Let me ask a question that Jose, I think, is alluding to, and that is the 8 inches per mile squared doesn't take into account viewer height, right? So you're not talking 6 foot observer. You're talking from your feet out.
No, what I'm talking about is how to quickly calculate hidden drop. Okay. This is what I worked out. This is what I discovered. 2 inches. So take the mile, times it by 2 inches, right? Or sorry, take the mile, square it, right? 10 times 10 times 2, divide it by 12, and then you get your feet. Right? Is that correct? Am I fucking up? That should be right.
No, you might be right, but then to do predictions on depends the variation on your observer height, it will be different every time, you know.
Yeah, but this is for a generic 6 foot calculation. Okay, that's all it is. Because Jose, you have to admit they're claiming curvature at such short distances. 3 miles, bro. Boats pass down at that optical apparent horizon point and move downward past it. That's such a short distance, dude. It's so short. You have to wake up, Jose. It's extremely short to have any. The Earth is massive, dude. It's huge. So why are we claiming curvature at such short distances? It's completely bizarre that we're just still here. I'm frustrated. I don't know how you guys don't see that it's impossible.
I know, but that's where, you know, so we're not here for, I mean, I would like to lump Jose into the category of open-minded. People like Brenda.
He's done a good job, man. Jose, you've done a good job.
Yeah, people like Brenda, people like Blue, those guys, forget it. Forget about it. No. But that goes, I think you touched on a point, what I was trying to make earlier, Flat Earth. And Danielle, I know that you're scrolling through some pics right now. Can you go back to your Google Earth, please?
This one right here.
No, the original Google Earth I'm sorry, not the Google Earth. Your video. Yeah. So the point that I was making to Jose and to everyone else is that right now I have submitted 5 pictures to a a baller. I don't know what else to call them. Ballers, whatever. Yeah, and his screen name is Barney. Barney has agreed to crunch the numbers, where he is going to do the maths to tell me in a clinical, pristine environment what we should be seeing. Now, my point is that because we have an inferior mirage going on right here,
Right, this should all be sand.
Yeah, exactly. So, I just don't see how. And again, I could pull up right now. I could go into my file right now and show you at 5.85 miles, at 5.5 feet to the shoreline. I've got it. To the shoreline.
Travis, aren't you excited? I'm excited. I'm looking forward for the next month or two when it get chilling and cold, a little colder, and we start eliminating this inferior mirage factor.
Okay, so
at least
Jose,
almost completely,
It's exactly what I'm looking forward to, dude. Were you on earlier when I showed them the boat? I had a remote control boat. I lowered my camera to the lowest.
I was looking, yeah.
Okay, so please just do the same
That's
thing.
gonna be great. That's
Yeah,
gonna be great.
I can't wait for it to be cold. The lake that I'm on is not even 3 miles wide, man, and I can duplicate everything we see in large scale and small scale.
Because I go, I mean, I take my P900 for a ride every time I go, and I take this kind of observations, small observations from 3 miles to 10 miles. I love them. 3 to 7 miles, I think, is my favorite, because we get all these phenomena going, all this mirroring and mirage, and I got a lot of those really good observations. I still call it inconclusive because it's neither here or there, but I'm looking forward then to the cooler days where we get less of this effect,
Why would you call it inconclusive? It's short distances, Jose. It's extremely short distances.
Oh, yeah. But when we get the mirage, it's inconclusive, yeah.
Don't you claim boats go down? Like I was talking to Rumpus, okay? And I gave Rumpus...
I don't. Please don't do that to me.
Well, I asked Rumpus just to confirm, right? Just to get him to admit it. I said, listen, man, the observer's 6 feet high. You have a 20-foot boat or a 30-foot boat. At 8 miles, this guy's claiming 15 feet of hidden drop, Jose. You're looking at curve dropping 15 feet at 8 miles. You have to be insane to even consider that to be possible without accepting the angles of light affect your eye. Come on, man. And the farther the light reaches out to the human eye, the smaller the angle gets, to the point where it becomes unresolvable. You must realize.
Can I answer to this point?
Okay, let me jump in real quick, gentlemen.
Yes, please.
Jose, you can give your answer, and then I would like to give it back to Danielle so she can work through her presentation.
Yes, and it's going to be a really quick answer. Thank you for the feedback data. Thank you for the answers and trying to corner me into these kind of conversations. I'm not going to do it today. I'm just enjoying the chat. Thank you, Travis, for inviting me. I'm just sitting here looking at videos. Please carry on, guys. Thank you.
All right, Danielle, back to you.
Thank you.
Sorry, I got distracted with all the chat.
That's
Yeah,
okay.
sorry, Danielle, my bad.
I saw a shiny bag of candy anyway, so. All right. So, yeah, that's 5.6 something miles. And then, stop. Okay. The mirage, as I'm going farther, obviously it's getting bigger. Right here. That's nuts. Back here, it was only...
Right. Yep.
It was this little thing.
Yep.
Which is not little, really, but... Then we have that. Okay, I'm going to let it play now. It was really windy and really, really freaking cold. This is Lake Michigan. In the spring. It was late spring. It was in May. So that right there starts to get where, it can barely see anything. And then these lights start flashing. What is that?
Can you steady your camera, please? Just kidding.
Exactly.
Yeah.
All right. So
go try to scroll. Yeah, there you go. Right there.
That is a light at the end of a pier coming off the shore here, because it kind of curves in and then it curves back out. And if you look at Google Earth, you can see that it's not.
Okay, so how did you interpret that light as a light on a pier? I'm asking,
So I was standing here and it curves in, and it's the only this is really where it starts to
Yeah. Okay.
out there.
Okay.
There's nothing else sticking out into the water. You can see the tree line, because you can tell in the video how it I'm following the curve around the shore.
Okay.
There's 5 miles.
So
and
how
then
far is the pier from the power plant?
that
Just curious if you
20
don't.
I think it was 22 miles.
Really? Okay, so think about that. Go back to that light, that light flicker.
22 miles. A little
Yeah.
over 22
Yeah,
miles.
that's fantastic. Go back to that light flicker. So we're looking over a flat plane.
Right.
And we're thinking of perspective and we're thinking of scale. To the left, you have a clear Fata Morgana, where you've got the sky mirrored below. So you've got floaty land or floaty somethings, right? Now we could possibly call that an inferior mirage if we got minute enough on the dark spots that we're seeing. We could call those inferior, but to me, it's too blurry. But I don't have a problem. Jose, you know, right? The ether band is a criminal because the ether band commits crimes 2, 3, 4 times at a time. 4 things at a time we got going on with the ether band. It's not just one. It's not just 2. There's so many different things. So right now, beautiful. That is fantastic. Think about the scaling of this. Think about the scaling of the distance of where Danielle is. She's 20 miles away. This, in my mind, the angle would be too acute. I would think that that light would actually be closer to the water line.
You can actually see the pier there. I'm saving pictures. I'm going to darken it up in the photo editor. All right. Hope I don't lose it. There we go. So there's that. Oh, it did like a half a second clip.
Mm-hmm.
See how you see the flash, and then you can actually see.
Oh, I see what you're saying. It illuminates what's beneath it.
Oh, you can see the lighthouse itself.
Right, so, that's what I'm saying. That's what I'm saying. With the flash, it illuminates the body of the lighthouse.
Try to pause it when the flash is on.
Right.
Just
I did.
Try.
I got a shot. See, when I lowered the light, you can see the actual body, and the one light is here, and then it looks like there's a light right on the water. So let's see, where's that?
You can just go back and use your magic with your space bar and just try to get it right there.
I haven't been back to the buildings, Travis, yet. Over here to the Tampa Bay downtown. I can't wait to go again.
Yeah, I know, man. I'm addicted to this. I would totally not show up for work if I didn't have to eat and pay my rent.
Depends what goes tomorrow after the show. I'll catch a bus, a public transportation bus, and I put my bicycle on it, and it dropped me like maybe 20-minute bike ride. So I ride 20 minutes to catch the bus. I catch the bus, it's like half an hour, and then when it dropped me, I got to ride 20 minutes to do the observation. I might do it, because why not? I really want to go and see it again.
Question for Jose and Travis. What is addicting about the whole flat earth thing?
Can you even answer that about any addiction? Like, why would you do that?
Yeah.
Well, you know? for me, sometimes when I hear the debates, I hear lies. So for me, I'm like, no, I got to make sure that, I've got that ego that's like, I got to correct that guy, which is nonsense, really. Because it's just it's polarizing. That's one thing. I guess the comments are polarizing me. But for you guys, what is addictive? The polarization for me, I guess, is the addiction.
Yeah, to me, it's not addictive to myself personally. What I enjoy a lot is taking footage, observing footage, and listening to people explanation and alternatives. I like the talks about Earth. I just enjoy it. I'm fascinated by it. Not addicted to it, but I really enjoy it. That's all. I just enjoy the talks.
Do you guys agree that the heliocentric model might be partisan, might be a political movement, or a party that has a belief system that's in power?
I never look at it in that way, and I will not. I will look at it just observations, down to earth science, and just random people just expressing themselves and exchanging ideas. I don't see anything political about it myself.
I wouldn't put anything past that supposition whatsoever. I wouldn't be surprised.
Here's the garage going all the way down to the water, the mirroring. you can see the light, and then it's all the way down. And when I first watched the video, I thought it was 2 lights, and there's not. There's
Yeah.
only one.
Yep. Yeah. So Danielle, so again, now you're in the position of Jose. I'm going to tell you, go if you could. You're in Kentucky. This is Michigan.
This is Michigan. Yeah.
Yeah, you got to get back out there. You got to get back out if you were able to, right? I'm not going to try to obviously put any constraint on you, but the only way to diagnose what you're seeing is to get out on another hour, another day, see more, see less, right? Because if you drew a line across if you went to the middle of those lights above the water line and drew a line, which would be your artificial horizon, right? So or your theoretical horizon, I'll say that because you're not really sure where the line is. But if the accuracy of the top light is the top of the lighthouse, then at some point that lighthouse is going to meet physical ground that you can't see right now.
Exactly.
Right? So do you happen to know how high that lighthouse is? Did you research that?
It's right here. Let's see. I'm not sure what they call that one.
Not only that, but while you're tipping and tapping away, that left image of those bushes or trees or whatever, like that would be interesting on the landscape where that physically is.
So
on the horizontal.
That right there. There's the lighthouse.
Okay, so do this just real quick. Just put in a Google search for that. What is that? St. Joseph North Pier Lighthouse. It'll tell you how tall it is. I'm just curious. So just Google that real quick, or Bing it, or DuckDuckGo it, or whatever you do.
I have a question for Eyes to See.
101 feet above lake level.
Okay, well that doesn't mean anything necessarily because we don't know at what elevation it is on the ground and whether.
The light was roughly 48 feet above the ground, but the bluff on which it stood gave a
Okay. Go ahead, Flat Earth.
Oh, I was just gonna say, Eyes to See. What gets you going about Flat Earth? Like, what got you into this? Just out of curiosity.
You know, I'm not really sure how I first came across it, and I was sitting and watching YouTube videos about something else, and I just something came up in my suggestion, and it was a video about the moon landing being fake, and I only had to watch like 5 minutes of that, and I was like, that's fake, you know, and I'd never even considered it before. I'd never even watched any footage. And then I get this video, and I can't, for the life of me, it's been over 2 years. I can't remember which channel it was on, but it had a person narrating saying, and it's great because I say this all the time, but my science book. And it's like, I don't know who that was, but they kept saying that in their video. And oh, whoa, did you guys hear that?
I did hear what you said. Yep.
No, there's a storm. I just had a huge, like, loud thunder. That was
No, didn't hear that. So basically, it was the moon landing kind of got you interested in the conspiratorial side of like, hey, I've been fooled here. And at that point, it was pretty much just like an open gate as far as like, well, what else can you show me? What else is there?
Right. After that, and I saw the something funny or something strange happened on the way to the moon. What's it called? Something funny.
Yeah, it's a documentary. Yeah.
I saw that.
A funny thing happened on the way to the moon.
Funny thing happened on the way to the moon. And I just, you know, when people don't want to hear it, I just tell them to go watch that. And
now, in all fairness, did you ever research that Bart guy?
I didn't research anything at first, any particular people, any documentaries. I just kept watching as many different things as I could. And then I was thinking, you know, I was looking at it's a mirage, you know, the guy showing you Chicago across the lake. I used to look at Chicago across the lake. I know it's not a mirage. And wouldn't it be upside down anyway?
So that was a pretty good indicator that the news was lying to you at that point.
Yes. And Oh, which I mean, when that newscast was made, I live in Kentucky now, and I actually live pretty close to the Ohio River, and I was considering going down to the Ohio River frequently because it's huge. It's really far across, and in some places you can get a pretty long distance of sight. You can get, at least 5 miles in some places. So I think that is something I'm going to try to pick up doing. And there's a couple places I can go to see, the sunset, and I have nothing blocking my view because this is like a foothill kind of area. So I have a lot of opportunities with water even to do this over and over. Not every morning, but I think I could get out there 1 or 2 times a week. There's
Will
actually
you? Sorry, go ahead.
well,
Sorry.
there's actually a bridge that you can walk across. So I was thinking I could stand on the bridge and make a video with, maybe if someone could stand at the bottom on the ground under the bridge and sort of do the same shot at the same time. If I could get someone else with a P900 to come here, and then we could shoot each other from across the river. We could do all kinds of things. And so I've got all these ideas brewing.
It's
Will
funny
you
that
allow
you.
me, Data? Will you allow me to ask 1 or 2 quick questions to
Of course,
Ice to
of
see?
course. Yeah, go ahead. Man.
Interesting. And Travis, my
I'm back.
permission.
I'm back. I don't know if you guys knew that I went away from the keyboard, but I'm back. So
No, we good. Ice to see, can I ask you 1 or 2 questions, right?
Sure.
So let's say you watched a funny thing happen on the way to the moon. When you watched this video, were you aware of some of the details mentioned in here, or were you learning it for the first time watching this documentary? Let's say.
I'm pretty sure I saw that on the first day.
Mhm.
This was all new to me. I had no
Okay.
idea that anyone even argued that the Earth was not a ball spinning, and
Yeah,
I
that's interesting. Yeah.
anything at all.
Now, when you continued watching some flatter videos and try to understand, what the content is and like the idea, did you learn a lot about the heliocentric model and the spherical Earth, looking through the eyes of some flat earthers? Presenting video, they say the heliocentric model proposed that this is the distance or the size, but this and that. It's an honest question. Did you learn a lot about Earth as we were taught in school through the eyes of a flat earther?
Well, actually, no, I didn't need to because I was already watching the opposite. I wasn't watching anti-flat Earth videos, but I was really and I always tell people, even on live streams, don't tell anybody this. It's a secret. I don't want anybody to know. But obviously, I'm putting it out there. I used to love David Wilcock. Don't laugh at me, okay? So I know you're all like trying not to laugh, but
He's a smart guy, but he's a little out there.
well, it's all to me now. It's all he's saying what people want him to say, and he was really out there in he was debunking current astrophysics, quantum physics. There's a whole lot of quantum physics stuff, and when you're sitting there watching him, you think, wow, I understand that, but it's like they want you to think you understand everything and you know everything about quantum physics within a week of watching David Wilcock present it all to you and tell you that redshift is wrong and Einstein was wrong, which I now believe Einstein is wrong. And he is sprinkling truth in there and letting people know real things. But at the same time, he's also saying that we are on a ball spinning through space, and he denies flat Earth whatsoever. And actually, I had heard him say that someone was calling him a flat earther, and I had never heard of flat Earth, and I didn't even think anything of it. I thought that was just wacko, but he's showing Earth and the dimensions of it, and the moon facing the Earth, the dimensions of the moon, the distance, why it always is perfectly, and that it must be some artificial thing. He's trying to convince you that it's, that it's artificial, that's a spaceship, and there's ancient recordings or whatever manuscripts, stones etched that say that the moon was here at one point, but it wasn't here before that. And so I kind of had, and the whole squaring circle Freemasonic.
Mute yourself, Mark.
Sorry.
Sorry. He did a lot of presenting on the squaring circle, the Earth, and then the area outside of it, and the way the moon's dimensions fit within that squaring the circle. And it's all, he doesn't tell you that's Freemasonry, which is ironic because they bring up Illuminati stuff constantly on the Gaia channel, which I was watching. And I was so into all this pantheistic stuff. So I had all of this, you know, dimensions of the earth and relative to this and that, and I was already understanding all those things. I think they don't tell you lies about that. They present that to you accurately based on their models anyway. Who knows what it really is, but I think we're having a pretty bad lightning storm, so I'm not sure. I don't think I'll lose power, but that's
Can I bring us back to Danielle? I don't even think we've scratched the surface of what you wanted to talk about. Do you want to
The observations. I got a quick last comment, Travis, and I'll promise I'll stay on mute. A last question or detail I want to put out there to the Danielle, right? Is that your name? Nice to see.
Yeah.
Last question. Do you, after you look into the flat earth a little bit and learn the heliocentric model and you knew a lot of idea, you research by yourself, do you watch debunking flat earth videos? What kind of, I'm almost done. So do you watch them? Yes or no? And why do you watch them? And I'm done.
Okay, sure. Yes, I do watch them because on one point I can see what they're trying to say, and in my mind I'm like, well, that's obviously wrong, and I can see kind of what they're trying to debunk and know what I need to address from that point. But also, there's always that, you know, I can't fly however many miles up into the air and look down, and I can't say with 100%, you know, certainty that the Earth is anything, because I can't go up there and look down at it far enough away to know what it really is. But I know I'm not on a ball flying through space, circling around a sun that's also flying through space in a galaxy that's also flying through space. That's ridiculous. That's insane. And you can look at ancient temples that, you know, and the pyramids and the Stonehenge and all this stuff that lines up with the stars, and that have supposedly lined up with the stars for thousands of years, and they're still lining up with the stars exactly the way they did. And they're trying to say, oh no, the stars are moving, the universe is expanding, but it's slowing down now, it's going to start contracting again. That's I'm trying not to cuss. I'm trying to hold my tongue on this, because when I get fired up, I kind of get a potty mouth. But it's so obvious in everything that they're presenting. So, but anyway, yeah, I go back and I look at them because I want to know what they're saying, and it's all regurgitated, and it's like, really, it's emotional stuff. They're trying to play on people's emotions. Oh, look at these stupid flat-tards, you know, and playing sappy songs, or like the funeral march songs when showing something about the flat earth. I mean, I've made 2 flat earth videos, one really, and then something adding to it, and I already have how many trolls? I mean,
I find that highly offensive because I have had so little troll activity.
Oh, no. Have you looked? I don't know what, I probably close to 500 views on that video. I made it just a couple days ago.
That's awesome.
I will say that I think a big reason for that is I would have to thank UAP. He has been plugging.
How do I find your channel? Eyes to See?
Yeah, it's the number 2 in the middle, and it's all one word. But
in the meantime, shout out to Good Times for All. He's in the chat. I think Toady is out there too.
Yeah.
Got Adelaine, Eternal Life. James is out there still. So thanks everybody for being here. Thank you so much. Flatza is out there. And yeah, so just having a good time talking. And
is it okay, while we're addressing, you know, the audience and stuff, is it okay if I do a really tiny plug? Something.
Yeah.
I want to go subscribe to you and go troll you in the comment section.
Stand by for other channel identifications here with Eyes to See. Go.
Thank you. Well, on October 27th, I'm pretty sure I'm getting that wrong. I don't know if any of you are familiar with the Fired for Truth channel. Nate from Fired for Truth.
Yeah.
Having a meetup with the author of the book, Crushing Conceptualism in Modern Christianity. And the subtitle is Exposing the Devil's Agenda Against God's Design. And I actually just got it in the mail today. I like to have 2 weeks to read it, but he's going to be there too. And so it's in Seymour, Indiana. And you can look him up on Facebook, Fired for Truth, or go to his channel. He does live streams pretty frequently, and yeah, he was fired from his pastoring job for going to a flat Earth, convention thing, and he wasn't even preaching it at church, and he got fired. So, yeah, I'm gonna be there. It's October 27th, and I think it's not a huge thing, but if you live near Seymour, Indiana, you should go. And that's all.
Just saying, I thought you were cute when I saw your little avatar with the glasses, but I saw you in your channel in a video just sending people over here, and you are cute. So just saying, throwing that out there.
Thank you.
Okay, Jose, back off there, pal.
Sorry, I put my shirt on.
I have a question for Jose.
Okay, well,
What's up,
actually,
Mark?
okay, hold on, Mark. Hold on. I'm sorry. Danielle, I really don't want to detract from your presentation. Is there something in particular that you want to talk through?
Well, really, I just wanted to show you that, this here in another location, being water, it's going to happen everywhere. And I really love the stuff you've been talking about with the mirroring.
How about this? Let me put you to the test real quick, Danielle. You ready? So walk through the ether band concept here with us right now. What we're seeing, what you understand about the mirage, what you understand about perspective.
Okay. Right here, I mean, I don't know, technical terms for.
Yeah, I'm not gonna grade you at all. I just want to hear it from another person and listen to it from a different set of eyes.
Sure. So you mean like the perspective? Like I'm looking here, I'm standing at, this is over 22 miles away. And I can see that this is not over any kind of curve. But I can't see like what's between here and here. I know this is the sky being mirrored on something. It has to be, atmospheric ether, which is what that is. The ether is the stuff in the atmosphere that causes this and that. And I think I really enjoyed yesterday. Was it yesterday or the day before? I'm so tired. When we were looking at that cruise ship being squished and stretched out, and it didn't really look smaller. It actually looked larger to me, just flat. And so I'm not sure exactly how you want me to describe what I see, but I do see that, I can see all the way to the shore, but there is this band of mirroring and distortion on. I'm touching the screen with my hand, and you guys can't see me doing that. But yeah, I'm not sure exactly how to explain.
I know that's a part, right? That's a part of the reality is not knowing how to say it, because we're talking. Right. I think, and again, whether or not I'm stumbling on something that hasn't been considered from other perspectives, I have not heard anyone address this. So until someone else can show me a timestamp where someone else addressed this issue that I'm talking about, I'm just going to say I'm the one, right? I'm the one talking about this to a certain extent. But
well, and did you see my video that I posted of this of my rebuttal video? I actually had a video of my I was in my car just a couple days ago, and this time of year you can see when the sun is setting, it looks huge. It looks 3 times the size it normally would, but only when it gets down there. And that's why I made that big, bowl shape, or that big long stretched out dome, because when the sun is like midday and it's 12 o'clock here, it's kind of it's south, but 12 o'clock, and it's the regular normal size that we would expect it to be. And then it gets, circling around. To me, it's circling around above us, but it gets down to the horizon farther out, and it looks way bigger, like 3 times at least the size. And that happens for a few days, in fall. It happens in spring. And people on my other video were saying, oh, there's no such thing as an ether. And I'm like, I'm telling people to come watch your videos, and I'm saying, look, you can see it. They're telling me that, oh, it doesn't change size. When you look up at the sky, the sun's the same size all day long. And I'm like, yes, I realize physically the sun is the same size. It's not growing or shrinking, but it looks like it's growing.
Yeah. You can imagine a 3-story building that you have all the specs to, and it's up in the air. It's not going to change physical size.
Right.
but the way that it is presenting itself to the viewer based on its elevation and whatnot. We've got another panelist that joined. Gleem, are you there?
I am. Can you hear me?
Yeah, I sound great. Thanks for joining.
Yeah.
So
Salute to one and all. I'm just preparing something just for a second, and
sure, great. Thank you.
I'd like to present something later on.
All right. Just put yourself on pause, and we'll
Yep,
let
sure.
Danielle finish up, and we'll hand it over to you.
Yeah,
Sure.
and thank you. And I guess kind of to wrap up, I just wanted to share the findings that I had in this that coincide with yours, because I love watching your stuff, and I'm waiting for the day you twist the end of your mustache. I haven't seen that happen yet, but
You mean like diabolical, like maniacally?
yes, it's gonna have to happen, but not right now yet.
Yeah. It's got to be spontaneous, unawares.
Yeah.
Unawares.
Exactly. Like, do you even do that habitually? But no, what I'm trying to present also, and I think this ether band down here by the water, I think you're right. I think it's an ether band. It's a concentration of whatever's going on there, and it doesn't have to be a 99-degree hot day in Texas on
No,
a car
absolutely not.
for you to see this. And but I think it's it's the same thing that's causing the sun to look different. Also, it's also the same thing, maybe in some little bit of a different way, but the same stuff that's making us have the sun go in a circle above our heads, and half of the time, on the equinox anyway, it's nighttime here and it's daytime here. If the sun was a sphere, I feel like maybe it's not a sphere up there, because if it was, wouldn't it be more likely that it would stretch even farther the light and not make those beam effects? I'm seeing effects where it looks like a beam, but ignoring that for now, there's got to be, the ether is obscuring the light from getting to us at all. It's blocking it, and I think the ether has a lot to do with dusk and night, nighttime. And when the light starts coming in before we can even see the sun, it starts to look, kind of daytime. And it doesn't in other places, like I know parts of I think, is it the North Pole or something? Like, they don't really have in like Sweden, like much higher north elevations, they don't have the dawn and dusk, the long periods of dusk like we do here, which is really sad to me. I love that, but I think that's to me, like, the first time someone mentioned that, I got so excited by it, how it's affecting our day and night, and there has to be an ether there for that to work, and at least based on what I've conceptualized about what the sun looks like, or the energy output of it anyway. And the heat, and they say, like, the higher you go up in the atmosphere, the thinner it gets. I don't know if is that even true, but it's cold up there. Why is it cold up there? Because you're closer to the sun, and you're through a layer of ether. It's the ether heating up the sunlight. It's not, if you're up there and it's freaking freezing, it's because you're close to it and you're not in a blanket of ether, like a thick, cuddly blanket of warm ether. And so I think that it affects that too. And there's just so much that.
So do you think that phenomenon is even quantifiable? Should we just live in the mystery?
I mean, I don't have tools to measure it appropriately, so all I can do is come up with my best.
Because I remember hiking in California on the Sierra Nevadas, and we got up 11,000 feet, and you just described that phenomenon, right? Okay, I'm 11,000 feet, quote unquote, closer to a heat source.
Yeah, you're closer to it,
and it's colder.
Exactly.
So I just don't know. Maybe that's like the difference. Flat Earth asked, what makes it addictive for you? Like, I don't know that I am actually curious to find out. I would rather just live in that mystery. Like, I don't know. Whatever. I don't know.
My curiosity is about the sun itself, like the energy. What is that? Because if you step away from a light bulb or a fireplace or any other light source, you're quickly going to cool off. The closer you get to it, the hotter it is. You're not going to have an ether effect on, I guess that is a really small light source, and I'm just giving this example, but even stadium lighting, you can be just 20 feet below it and it's not going to burn your head. But the sun, if it's it's huge, and you're getting to it and you're cooling off. That, what is that energy? And it's playing with the ether, and the ether is playing with it, with the energy, and that excites me. I think that's just terribly exciting.
Awesome. So that's what we're here for, right? So I can focus on what I'm focusing on. You can focus on what you're focusing on, and the dance shall begin.
Yes. Well, thank you for entertaining my footage here.
Oh yeah, fantastic! I love it. Thanks so much.
So,
all right, so if you go back up and unshare or stop sharing, then I think that'll allow Gleem to step up.
Thanks for hearing my rant, guys.
Not at all, Danielle. Thank you. Gleem, you there, buddy?
He's making a coffee.
He's making a coffee. All right. What's up with you, Mark? What are you doing? What's going on with you?
I've got a question for Jose, if he doesn't mind.
Jose, you around?
I'm here.
Just an opinion, Jose. I'm not going to make a counter argument. Danielle there played the incredulity card, and I play it as well. The idea that we're spinning and rotating and moving 4 different directions at such vast speeds, I find that too incredulous to accept. What's your opinion on that?
I was in that boat. I didn't believe it at all whatsoever. The movements, the curvature, any of the claims of the sphere. I was like so 100% flattered. Yeah, then I went through a little shift that I was like, it might be not. Right now, what I just decided to adopt everything that the globe preaches, and I think it works unless I'm presented with an alternative. That's where I am right now. I'm not saying I'm going to preach it forward, I'm going to push it, and I'm going to call flattered ignorant or retard, but because flattered taught me to question everything. Now, I decide to adopt the globe because everything can be modeled and presented in a solid way with citations, with evidence. Flat Earth still lacking a lot of evidence, a lot of citations, a lot of things. So I go to the globe side where it's already there, existent. When I'm presented with alternatives, I'll start not adopting them, but I start looking deeper into them.
Can I ask you the question again, because I don't think you answered it?
Yeah, go ahead. Ask me again.
It's the incredulity of spinning, orbiting again and unorbiting again from the original Big Bang point. That movement that I do not experience. Have you got any thoughts on that particular thing?
Yeah, everything. Yeah, I believe everything is happening as we are told now. If I decide to put myself in a third point of view, and I want to see the movements super fast and super flying by and all this moving around, I'm not going to believe it. But I have to believe it because everything happens in a slow pace because of the scale is so gigantic that you cannot grasp. So I had the issue, I could not scale it in my mind, and I saw everything in fast motion and in a tiny scale in my mind. Now, if I think the vast distances and the vast scale, then I can grasp, and I say like, oh yeah, everything is happening the way we are told. All the movements, they are happening, Mark. We just cannot grasp the scale.
Shout out to the great scale negator.
Okay.
Amen.
I said I wouldn't give you a counter argument, so I'm just that's fine.
I am. I'm going after him right now.
Do it.
I'm just kidding.
Oh, let him say. Come on.
All right.
You know.
Danielle, did you want to say something?
Yeah, I have a little question about that. So adopt the globe, whatever. I don't attack globe people either, and I don't. It helps nobody on either side, but. Does it not bother you that, supposedly at the equator you would be spinning 1,000 miles an hour, and then you would weigh what you weigh now and not being flung out into space, not feeling squished down to the ground by this dramatic amount of gravity, but then you go up, a really high, extreme north near the North Pole, whatever, and you're not spinning nearly as fast. You wouldn't be affected by the, centrifugal force of Earth at all, but you weigh the same and it feels the same to you. Does that not bother you?
It doesn't bother me. It used to before when I didn't have when I couldn't visualize it in my mind because I saw everything through a screen and small models. But As for the numbers, I mean, the scale, like the degrees per hour, the movements of everything, is you just have to look at it not from it's moving at 1,000 miles per hour. You just got to look at it as 1 revolution per day, for example. It's the way you approach the subject and not the way it's presented to you.
But it is supposedly moving 1,000 miles an hour, and that's a lot. So,
Oh yeah, but 1,000 miles per hour equal 1 revolution per day, and it's all relative from where you are on Earth.
All right, shout out to Right the Hand that did like a 4 or 5 minute expose on revolutions per day. So we'll let it drop at that. Gleem, you ready? You ready, Gleem?
Yeah. What would be best? I totally understand if you don't want me to screen share, but I've got 3 documents which are up on the web.
Oh, I don't care what you do, man. I'm not monetized. I don't care. Share your screen and go at it.
If I could give that a crack, share, and
yep,
is everyone seeing
orthographic analysis? Yep.
Yep, and really with this, I'd like both flat earthers and globe earthers' point of view on this, or at least acceptance or just a head nod. Because Jose, I'd love to present this on your show because I've had so much stick off of your show, from the likes of Al Kay, Sean Hufford, for my perspective formula or my perspective maths that I've just made up. So what I'd like to really ask is that everyone on the panel is, I just want to agree. I'll read the background into why I've done this, and I think this is literally gonna slew every single globe analysis, as well as provide the basis and the foundation for a flat Earth model. So either way, I'll read my background there, and what I'll do as well, if anyone can't see it too well, is I'll post it in the Hangout side chat. And yeah, I can do it in your normal chat as well. So anyone can load it up. And
maybe Travis, one moment, send me that through Skype because I'm on my phone and I'm not going to be able to save it.
Okay.
I'm not in my laptop now.
All right, got it.
Okay, yep. So basically, the way how I see it, let me read it either way. A common trend in the globe Earth community when analyzing long distance photography is to use the orthographic side view. The flat Earth community strongly oppose this analysis as they believe the orthographic side view removes all account for perspective distortion due to distance, i.e. the apparent rise in floor, the apparent drop in the sky, the apparent reduction of your width of field as it goes through. And I've added in there as well, obviously, atmospheric effects, which is exactly what you were just talking about and exactly what you're king of at the moment there, the plain truth. So ether band, and obviously with Nathan, with his approach, and Jose was fully involved in this, not holding that against him, but he was fully involved in the angle of incidence or angle of attack or whatever he called it. And what it basically is foreshortening. But basically, flat earthers are saying, no, you shouldn't take it in this orthographic view because this removes all accounts for perspective maths. And this is what allows things to be hidden on large scale, let's say. And obviously, Travis, you have your ether band, which is always there. But I think I've seen a couple of photos where it's not as predominant. And I think that's more because they're not as zoomed in as much.
Yeah.
If you understand.
Yep.
Yeah. Where if you understand the quality difference, the pixelation difference between some of the real close-up shots where you're seeing that wave phenomenon where it's like disappearing. But anyway, I come from a view of there is a geometric to perspective distortion which should be transformed, which all globe earthers, all flat earthers should follow a formulation to say, right, I've just taken a photo, this is a view, here's my input numbers, this is what I need to account for as an error for my perspective. Okay, and no one does that. The globe earthers never do that. They just chuck it into this orthographic view. and use the basic angular diameter formula, which is listed there. I don't know whether you can see it. It's, everyone knows it. The Rumpus has used it
Except for
multiple
me.
times. Well, either way, it's just basic angular size change. Okay,
Yeah.
so this is what the orthographic view is very good for. It is good for removing any perspective distortions and analyzing the true geometry. Now saying that, it's that bit I don't have a problem with. The problem I have is that no globe earther transforms, which is a common thing in maths. You transform coordinates to do projections for maps and stuff like that, but no one transforms from a perspective view into the geometric orthographic view. And
I've thought about that abstractly. I really, as I've driven along in my routes, I've actually thought about this. So I appreciate you bringing it up.
I have thought about it also, Gleem. I mean, I think you have seen me when I first started popping in the flat earth debate, and I did my first participations was with paper and drawing a little bit of perspective.
I remember that, Jose. I remember that.
Exactly.
I do.
That was when I started getting the void, being heard a little bit more. I say, I don't have a computer, but I got paper and I got understanding on perspective. I tried many times to do a representation of perspective, what we see, like the walls appear to close, the floor appear to ramp up, and the perspective effect. I tried to do it in orthographic view, but I couldn't make it happen, like realistically as a you know what I mean? I have tried, and I haven't grabbed again a paper and pen because I think it's better to do it that way instead of a computer model. For me, it would work better to grab a physical paper and pencil and some rulers and just observe and try to draw it sideways. I'm gonna try to get motivated in the next few days and try to draw a little bit more because I like perspective drawing.
Sure. But the whole thing is from an outsider looking in. Let's say I'm an alien coming into this for the first time, and I've watched a few videos on flat Earth and globe Earth, albeit I have actually been involved and been in the scene. Everybody or a lot of people know me for 5 years or whatnot. But either way, let's say I'm an alien coming into the scene. Is that a good assessment? That a lot of globe Earthers, when they do their analysis, they put it into side view. And a lot of curvature calculators do exactly the same thing. They're looking at it from a side-on geometric point of view rather than looking at any perspective distortions, because that's...
Me personally, I don't think you can put the observations that we have from a first-person point of view, a zoom-in image. I don't think you can show it in an orthographic view. You can't, because the angles and the sizes are too small compared to your size. It cannot be scaled. It cannot be scaled in one picture.
Yeah, no, you got a very good point. I mean, in Photoshop, you can actually go up to massive load of pixels. I've been set a challenge which I'm in amongst at the moment. But if you take 1 meter per pixel, you can get up to sort of like 40,000. I think the limit is. So that's 40 kilometers. So you can represent it that. Obviously, it's 2 pixels high. And your lines are only 1 pixel, so it's going to look very different and very difficult to work out the angle. But anyway, back to the picture. I just want a nodding yes. This is the actual argument, or this is an argument of the flat Earth that flat earthers say no, you shouldn't take it into orthographic view because, I mean, I think Nathan's phrase, I can't even remember it all. Jose, you'll probably be able to help me. It's the lumen refracted hyena hijacking of perspective side orthographic curve calculator or something like that, doesn't he?
Yeah.
He says that. So just from an outsider looking in, and again, Jose, put it this way, even I'm glad I'm first presenting this on here because I've presented it a couple of times on your show, and it's literally been a laughing hyena fest where everyone has laughed at me and everyone has mocked me for presenting this maths. And
it's not fair. Yeah, I don't think it should be like that.
Yeah, that's it. And mono, man to man on this, I don't hold you responsible for any of their actions or any of their words or anything like that, or mine. It's you are providing a platform, but as their manager, I'm glad you're here put it this way. So have I
I'm no
represented?
manager, man. Come on, I'm no manager. I'm nobody.
You
I
are the
know what you
manager.
mean. I
bro.
know what you mean.
You are the court judge, bruv. Come on. But either way, in grand scheme of things, from a flat earther's point of view, have I got that right? From a globe earther's point of view, for all the rest of the globe earthers as well, have I got this argument correct?
Hey, Gleem, this is Flat Earth Data. Can you hear me?
Yes. Hi. How are you?
Yeah.
I like the argument. I like the
I
argument.
appreciate your orthographic view. Did you see what I presented earlier?
I did not. I've literally just had. I have mates round to watch the UFC and whatnot.
I gotta get out of here. My phone is in like 5%. Thank you, Travis. And I'm just telling you, in the last 10 minutes, I've been too distracted looking at eyes to see, so I'm barely looking at.
Hey, listen,
Travis.
listen.
Beautiful young lady. I'm sorry.
No creepers here. No creepers.
Jose, I'll send you an email.
Nice meeting you guys. Nice meeting you. Nice to see. Nice talking to you, Mark, Data, Gleem, and Travis.
Jose, hold on. Before you go, check back in at the close. I've got a special close for everybody. So if you get your phone charged back up, join back. Okay.
Okay. Oh, we'll do.
Okay.
I might join from the laptop actually. Throw me a link on my Skype.
Okay,
so if I open the laptop, I'll do.
Will do.
Perfect. See you. Thank you, guys. I'll keep listening.
So yeah, just to cut to the chase, either way, on this thing, I think I'm representing it right. I have got a citation there that just basically says there is a difference between perspective viewpoints and orthographic, and that difference is the perception of distance. But the one question I want to ask both flat earthers and globe earthers is that globe earthers normally say the angular diameter formula, which is just your basic angular size, is the only formula you need. You don't need any other formulas. It is just literally put it in that side view and then do your angular formulas.
Yeah, that's where I come in and I say, what about the atmosphere?
Yeah. On paper, it sounds right, but yeah, exactly. What about the atmosphere that the...
Gleem, I have a question for you.
Sure.
When you look at Maxwell's equations, they also don't add any atmosphere in their equations, do they? They basically, so it's like just a general theme. It's really between Euclidean and non-Euclidean, and between ether and no ether, basically.
That is the thing. I'd like to talk from a perspective of absolutely no or equal amounts of atmosphere. In let's say most ideal, perfect conditions where there's no distortion from the atmosphere. This is just purely a perspective thing. The bombshell I want to do is there's just two questions I want to put to Jose's panel, and I want to ask them this, and I want to record everyone's answers as well. And it's just basically, I want to understand whether they think that the current analysis that the globe earthers do, put it in that side view and just do the angular size, measure it out and say, look, it doesn't work, because then when you put a curve in there, it does work, because this is how much is hidden. The second question to follow up is, I've presented this many a time, where there's a formula which also has been presented by Life is Short. Shout out to him. And it's literally where your apparent false horizon is. It's how to calculate your apparent false horizon. And all it basically is your height over divided by the tangent of your angular resolution limit in radians. Now, I've been slated for this one formula. I've been banging this formula out for about a year. And seriously, so many globe earthers have literally said to me, no, this is absolutely made up. This is a load of nonsense. I've had Rumpus slate it. I've had that Dean guy, hundreds. Yeah, Stingray. Literally hundreds just saying, you've made this up. This is absolute tosh. And it's actually based on trig, which I got the formula from, it's Excel. Because I do all my calculations and maths in Excel. So it's an Excel trigonometry cheat sheet that I got it from. And it's just the same. It's to work out a triangle. If you've only got an angle and you've got the A to B side, you literally work out how long the hypotenuse is from this particular method. So either way, everyone's been slating me. And what I want to ask everyone, or ask specifically the globe earthers, the ones that have been slating me, is should you ever account for this apparent rising floor? Now, I don't know whether you see on my thing here, I've got the formula in there, but you've got an apparent rising floor, which is a perspective distortion, let's say. It's a distortion that you have to account for in my eyes, and I've always spouted it out. Now, everyone, it was Hufford. Hufford was the last one. I'd been on the stream for a couple of hours at Jose's.
Can you zoom back out a little bit, please?
Yeah, sure. But Hufford literally goes, right, let's test your formula. And he kept me hanging. I was actually in the need for a loo, and I kept there for 20 minutes waiting for him to give me his answer.
I remember that. I was there, and the drove me absolutely nuts.
There we go. And I was just like, okay.
Word.
And then next time when I come back, I was slated for running away, and I was like, no way was I running away. I give everyone forewarning. Look, I need the toilet.
Absolutely crazy.
Yeah. But I really want to now slam dunk the
Can I
whole.
ask a question real quick?
Sure, of
Can
course.
you zoom in just one time?
Yep, to the observer.
Yeah, right there. Right there's good. So
Yep.
no, back out.
Oh, back out one. There we go.
So that line of tangent from the observer's eyes.
Yep.
At the fulcrum, or whatever that point of angle is, you've got
Yep.
a really wide obtuse angle. I'm trying to understand what I'm seeing here from a orthographic perspective. Why do you have the horizon ramping up on the left or the ground? Why do you have the ground ramping up to the left to the point of the arrow, and then it flattens out?
Right, because that is your convergence point. The way how I see it, that's
okay.
it's your convergence point for the same height that you're at. So if there was two 6-foot people, basically, life is short goes right through this in very great depth, a lot more depth. I will make a confession straight away. I was banging this out in Nathan's, must have been 8 months ago or something like that, and then I see Life is Short saying the exact same formula, and I was like, oh, he's seen it from me, and he's spouting it out. So I checked his channel, and then I found his 3-hour video. And I was like, no way did he get this from me. I haven't gone through to this depth, and salute to him. He actually broke it down so much.
I would love to go through that stuff. It's just, so
he broke it down into 3 1-hour ones, and it's much more digestible like that. But I was avidly proper. I'd done the whole thing in one sitting, obviously just breaking for cups of coffees and whatnot. But no, I was avid, and I was loving his... put it this way, he's using raw data and real world data down that hallway. He was actually doing it from different angles, showing an actual thing happening, an actual phenomena and compression and whatnot. But to get right to the point, I've been basically ripped the hell for presenting this formula as maths to describe what could be blocking. And there's loads of things that I could go in depth if you want to know more, but I want to really just cut to the chase. And what I really want to present on Jose's, and hopefully he's still listening in, is that I want to get everyone to agree of what they've already agreed with and slated me on, to say, no, you should never account for this apparent rising floor. You should never account for this apparent drop in the sky. These are just...
picture I could show you that it perfectly shows what you're talking about.
Yeah, no, I did present one. If you remember, Travis, the one you went, boom, you just killed it with that one picture, I think.
Yeah.
Unless it was basically this one where the plane's going off into the distance.
Yep.
Yeah, and obviously it's staying at exactly the same altitude. And I've done this on the maths of Polaris on a flat Earth, and I've made it work to a perfect T, where you could give me any degree, and I could give you based on the formulas and the maths, I could give you the exact mileage to the zenith point on a flat Earth, and it would work out identical to a globe. Yeah.
Gleem, Travis, do you mind if I show Gleem what I showed you guys earlier regarding the radius of the observer?
Oh, give me 1 second and let Danielle, if you want to share your picture. Do you still want to do that?
Could I just close off with one
Okay,
final
sure.
bit, and then
Go.
I'll pass
Yep,
the
okay,
floor
thanks,
straight
Gleem.
over. It was just one real final bit of just basically presenting them, because you know how they all say, oh, you haven't got any science, any maths, any science, any model or anything to back you. You're completely flat Earth has got nothing. And then you look into this phenomenon of the apparent rising floor, and you see that back in 51 there was a massive investigation into it, into the perceived distance, because there was people who had done a test, and the angular size, just the angular diameter, wasn't working. People were perceiving things closer to them than what they actually were, and bigger, as if it was magnified. But in this one document here, which is a 2007, I think, there is the exact formula that I was using. And what they call it is an egocentric distance, which is basically a perceived distance or an apparent rising floor. It's just my terminology is different to this. And if you look here shows the perfect thing of how they're representing it. What it is that is my sum there. That is my formula, height, the tangent of the angle. And that's exactly what this is. But then they're saying, no, wait there, people are perceiving it up here closer because of this slant error. And this slant error is the perceived ground. And it's to do with foreshortening, to do with your illusion in your head. But it's perspective. It's the nuts and bolts of perspective.
It's stereoscopic translation between a 2D to 3D perception, correct?
Yes.
Okay, one more time. I'm in kindergarten. What? Yeah.
So your eyeballs human beings see stereoscopically, which means we see two-dimensional, but our brain interprets that two-dimensional imagery into three.
Exactly that. Yeah.
Okay. So can I show you, or is it Danielle? I'm sorry, eyes to see. Is it Danielle?
Let me stop screen sharing.
Yep. You know, honestly, mine is so quick and back. I'd rather go back to you. If you're done, Gleem, great.
I'm done.
Oh, you're done. Okay.
Yep.
That's great. It basically reamplifies what I was showing these guys earlier.
Right. I wasn't here earlier. I'm so sorry.
No, and it'd be great to wrap around. But real quick, Danielle, did you just have an image? Come off mute.
Sorry. Okay. Here, I'm standing on the shore right before I walked out onto the pier to take this picture. So the camera is probably 4 feet, 5 feet above the water. And it just looked, even standing there just looking at it without using my camera, it looked, I hadn't seen the lake in so many years. It's like it was rising up so high.
Yeah. It's amazing. I appreciate this so much. Go ahead, keep going.
So, but that's it. I just wanted to show you this picture because I thought it was such a perfect example of that floor rise. Because I'm not pointing my camera down at the water. I'm pointing it straight out.
Yep. Fantastic. Thank you.
Mm-hmm.
All right, Flat Earth.
All right, so this is just to really sum up what I said earlier. Basically, I've done here. Gleem, can you see this here? I'm basically this observer here at the shore, right?
Yep.
And I'm looking outward.
Oh, I did see this video. Yeah, and you put the circle around. Yeah.
Yeah, well, this is 3 mile radius. So this piece here is the apparent horizon based on our angular resolution.
Exactly.
Right?
Yes.
So what they're claiming, and I tested this with Rumpus. I said, Rumpus, if you have a 30-foot boat, or I think 30-foot boat, let's say, or 40-foot, doesn't really matter, the size of the boat in this example. But let's say we had a boat, and I said, how much would be 50% of the boat? How far would you have to be? And he was like, okay, you have to be 8 miles away to get a drop of about 16 feet, or give or take 12 to 16 feet of hidden of the boat.
Yeah.
Right. So if we had a 30-foot boat, it would be maybe 12 feet of it left remaining at this point, right? Do you understand the second radius line here according to it?
That's it.
This is the math, right? So the problem is you'd have to take the observer, you'd have to zoom in with the camera, right? And then you would get this optical compression. You would see is this angular resolution here of the second or the first line interfering with this boat, right? Or interfering with the angle of the camera. It doesn't change. It's just now compressed into the viewer viewing lenses, right? Like thicker lenses and how the camera works. You're just taking the same angles of light, right?
Yep.
You're compressing it into the view. Anyway, the point of the video is when you zoom out, you're actually claiming physical curvature at extremely short distances. Like this red line is past the observer's vision and it's moving into the second line being obscured by curvature. It's absolutely insane.
That's it. And the drop as well. You don't
drop,
witness the drop.
How's the drop at this? Like it doesn't make. Okay, so that second mile is the boat at 8 miles. So if what the math says is that if the boat is at the second radius, right, that the observer standing here will see 50% of the boat roughly. So there'd be like 15. The math is varied depending on refraction, all this other crap. But basically, you've got about 16 feet of the boat, I think. No, it's not that. I think it's maybe 12 feet. Yeah, I forget the math. I apologize. Yeah, it's about 12 feet anyway. I can't remember because I added some things in it and refraction, all that stuff. Yeah, I think it's between 12 and 16 feet of hidden. So this is why the boat is obscured. They're claiming that between this distance and that distance, you're going to get bulge. And all I have to say is, look, man, zoom out. You're telling me there's bulge there? You're telling me there's physical curvature there? You have to be a complete moron to not see what you're saying. No offense. So that's why I wanted to show you Gleem just to.
Yeah, no, that's it. I did watch the video as well. I did watch the video and jealous.
Okay, I showed this on Red Pill yesterday.
Yeah, that's where I probably see it. That's where I see it. Yeah.
So to me, this is just if you take in angular resolution and you take the observer at this position, you can see that this immediately dispels the idea of physical curvature.
That's it. See, I see it as a that inner circle would be. I don't know whether you can click this link. Give me 2 seconds. I do a big old 5-6 empirical steps on how to make stuff disappear from the bottom up, just using perspective.
Yeah, I've got a video. Would you like to see another one that I've done to back this video that I did?
Go on.
Hit us with it.
Okay, sure. Well, you guys already seen it, so it's kind of like a repeat. But
okay. Yeah.
You know, but I'll bring it up again. Just give me 2 seconds. Basically, it's a perspective test. What I've done and what I've suggested anybody to see how angles work is to take the lens, cut 50% of the lens off at the bottom, level the camera out, have any object stand in front of it, and you will see that as due to distance, you will see the angular reduction go behind or appear to go behind, but it's just reducing in angular size, right? So here's the video here. Sorry, guys, I just forgot I was going to do that. So I'm sure you've seen this, but I do it over water.
Yeah.
And I do
no, I did see this.
I do it over a distance of 2 feet, right? And you can definitely see when I cut off the angle at 50%, objects will appear to move downward due to reduction in angular size.
That's it.
So anyway, I don't mean to take up the time, Gleem. You're brilliant. Every time I hear you talk, I have to whip out a piece of paper and a pen. So,
well, I need to send you all of these other 3 links, but just while you're sharing, I've just posted in the side chat. If you can just bring up that, and I'll explain how I try and explain it to globe earthers to try and visualize. I mean, some of the first easy steps. The core of it is, I say, the closer you are to any surface, the more it fills your field of view. So I say, walk up to a wall, put your nose on the wall. You'll only see 50 centimeters of the wall. take 2 steps back, and you'll see all of the wall. So same thing happens in a vertical manner, where the closer you get to the floor, the less of the floor you're going to be able to see. And if you just add that up, sorry, yeah, if I go on there, so if that's a football stadium, and how I explain it is that the if you're standing on the middle of that, you have a circle where your apparent rising floor is not actually rising, but what it's doing is it's those seats, the rows of seats going back, is mimicking this apparent rising floor. But this is actually going to cause a physical blockage at a point. At a certain point, things are going to start to disappear bottom up.
I believe I have it posted up, right? You guys can see it?
Yeah, I've clicked on his icon and it's up there. So how I normally explain it is, this is obviously on a very squashed up scale. This would normally be real flat like a pancake and squashed out to be 2 meters high, the height of a normal person. And the rim of the actual football stadium roof is your apparent horizon line. Now, to re-shrink it all back up again, to be a normal football size thing, if you imagine a crane with a wrecking ball pulling into the car park there, if you're a little person standing on the center spot of that football pitch, you won't be able to see any of the crane. You may be able to hear it, but you won't be able to see any of the crane at all. As it draws nearer to you, and this is just distance away and to you, you will start to see the tip of the crane come over the rim of the roof. Yeah, and then you'll start to see the top of the wrecking ball like the sun is rising. And then as it goes round the whole stadium, it then sets the other side and does the same thing, starts disappearing bottom first. So that rim of the roof is caused by your perspective, and it's based on your height and your ability to resolve. So everything in front of you ramps up, appears to rise up.
The problem with what I encounter is they can't grasp that angles. So the way I kind of equate it is like the double slit experiment, in the sense that when you split light, it will diffract and cause a pattern, right?
Yeah.
So why don't they look at eyesight the same way over distance? Because really, that's what I think the horizon is happening. What's happening to the horizon is essentially the split experiment, where because our eye is literally a circle, the aperture, the light will diffract at a certain angle due to distance.
Yep, that's it.
So our eye is subjected to that. And what I find that they can't compute is they can't compute it causing a physical obstruction. That's the issue. They don't want to conclude that the angle becomes too acute to resolve could possibly be that physical obstruction. They have a hard time tying that together, I find.
That's it, because I think Barney gets some of it, because he was saying it's not a that's as far as you can see and that's it. It's your visual acuity of your 0.02 degrees or 0.016666667. That is not a limit of how far you can see. That's a limit of how high or how far you can see based on your height.
Can I jump in real quick?
Yeah, carry on.
So, I was just reminded of the time when I thought about the naught, or the point naught, whatever, the 0.02. I was driving, right? I was driving, and I would have needed one of those university-sized wall blackboards with a ginormous piece of chalk to write out what I was thinking. But I as I was listening to whatever I was listening to, and you guys already might be here, and that's great, I was thinking the curve calculator is simply an extension of what we see naturally. Like I had this epiphany that what I was hearing was the description of what our eyes see physically. Okay, I get that. Okay, yeah, I get that. And then I watch another video on a a heliocentric model of curve calculator, and I go, that's the same thing.
But it has an R on it on the equations on the mathematics, Travis. It has an R on it. Yeah, you know what, man.
Well, do you want to see something real interesting? If I can just
Bring it up.
Share the screen again.
Let's take a little look.
Welcome back, Jose. Welcome back, man.
Thank you.
I think you have actually presented it before, Jose, on your channel. It has been presented somewhere there, but it's basically this is my angles to Polaris, and the only bits of information that I've used to create this are that for every 69 point whatever it is to I think 3 or 4 precision digit precision, sorry. For every 69 miles you move away from Polaris being at your zenith, it will appear to drop in your view by 1 degree. So I've just done that based on that. So you step away 69 miles, Polaris is no longer at your zenith. It's at, instead of 90 degrees, it's at 89. Okay. So
hey, Gleem, sorry to interrupt you. I have a question though, sir. Just sorry to interrupt you.
Sure.
There is no picture of Polaris at 90 degrees.
No, was that yourself that just recently put that out? I remember someone saying that, and that's
I said that yesterday on Red Pill Philosophy's channel.
Yeah, well, that was you, and you know when you hear something, you're like, nah, can't be. And I went searching, and you're right. I cannot find one where it's directly upwards. They're all on the horizon. They're all
at that 23.5 degree or 24.
That's it. Yeah.
I went on ESA,
that was interesting.
I went on ESA, I went on NASA's, I went everywhere, man. I went old archives. I cannot find one zenith picture of the North Pole.
Yeah. No, seriously, I looked up and I was like, surely not. Surely there's got to be hundreds. And
so I got homework
today.
Loads. What's my homework today? To look for a picture of Polaris from a 90-degree angle.
Okay, I just need to stop this whole discussion for just a moment. Jose, on your channel today, someone called out the fact that the y-axis was the z-axis.
Yes, Bob.
Yeah.
I noticed that.
Yeah.
And he tried defending it.
Bob, the
I was
what?
like, no. I remember that.
All right.
I was like, sure.
I'll back off right there.
I didn't even catch it. Yeah.
Jose, you got homework, bro. You got homework, brother. Polaris, 90 degrees zenith.
Beautiful. I'll look it up. Yeah.
The Z-axis. Remember, Z-axis. Not what Bob was saying. Bob was saying, well, it's always been Z wherever I've been. And I was like, no, it hasn't. X-axis has always been horizon.
All right. So if we locate it on the globe Earth, 90 degree will be in the North Pole, right?
You got it.
Yes?
Yeah. Okay. Perfect. So it doesn't matter if it's X or Y. Visuals of Polaris from the more centered part of the North Pole, I catch.
Yeah.
I'll look it up today.
Not the more center, the zenith.
So directly upwards. So as if it was solar noon, where the sun's directly above you, but it's Polaris directly above you, and you'd have to be directly in the middle of the North Pole.
Polaris noon.
Polaris noon.
Shout out to Polaris noon.
shout out to Eyes to See. I cannot stop looking at this beautiful young lady. Please don't turn off your camera. Don't do it.
Turn off your camera, Danielle.
But yeah, so if I can
save yourself.
If I can play my animation, the two bits of data I've got is that So either way, I put those 2 bits of data in a table, and just worked it out on a flat surface. And if you see this happening here, for every 69 miles going down on the horizontal x-axis, the y-axis there is decreasing until it gets to the equator. And then finally, Polaris is gone.
What? Go back to the beginning. What? Go back to the beginning.
Right.
But that's a drawing of perspective there.
That's it. It's like an orthographic, but account for perspective. My actual column name is apparent altitude of Polaris. Polaris will always stay at the same altitude, similar to that plane. But as you move away, or as that plane's moving away from you, it's appearing to drop in your perspective. So exactly the same with Polaris. As soon as you move away
Okay.
from it, 69.
I have just like elementary question. Stop.
Yep.
Your very right axis point. Is there any way to plot out distance on that, or is this just some kind
All of this is 1 degree. So how I've done
69,
it is
69. Okay. Okay.
Yeah, that's
okay. I got that. I appreciate that. Yes, I see that now. Okay. Okay. Got it.
Yeah.
I got it.
Your beginning marker is zenith. Then you're presupposing you're there at the zenith and you're working your way back. Okay.
Yeah. You start here. So this is 69 miles, and I've done it to scale. So that's actually 0.69 centimeters.
And correct me if I'm wrong. This when I looked at this in the past. This derives back down to 8 inch per mile squared. Last time I checked.
It probably would, because if you see the arc, that is the arc of your perspective.
Yeah. Well,
and if you see, that's a quarter of Earth.
Exactly. So when you do the 360 degree or 24,901 divided by 360, you get the 69.169, right?
Yeah. Yeah. That's it. Yeah.
So when you
that's the degree.
Yeah, so you're still deriving the 24,901 into 8 inch per mile square. So it's you're using the base derivative is the 3963 or the 24901, right? Or the what is it? The 6 times 224.
Yeah, I think it's 6,000 miles, 6,214 at the equator, from North Pole to equator.
All right, so let me jump in real quick, because I think I asked this one time on Nathan's, and I don't remember it getting answered very well. But it was when I had this epiphany. So my process was, okay, you're telling me the answer is, well, it's only 1 degree. Okay. But if I don't know what the value of that 1 degree is, your answer is meaningless. Absolutely meaningless. So then when you tell me that it's 69 miles, and then I can correlate that to 8 inches per mile squared, my thought process was, you cannot then negate the degree from the measurement of the 8 inches per mile squared, because you have 69 miles within the degree. So if you tell me that there's only, that's only 1 degree, but there's 70 so-called miles, that's like, I think over like 3,000 feet of curvature, or something. It was pretty large. But my point was, you can't separate those two expressions. You can't say it's very insignificant because it's only 1 degree, because the 8 inches per mile squared at 70 miles is huge.
Straight away.
Right? I mean, I'm asking you. I know you're on my side. Am I wrong?
Well, no, you bring up a good point, because the degree wouldn't be as exuberant or as parabolic, right? Based on that suggestion, over 70 miles at the 8 inches. But I believe, do they not? I mean, they're so inconsistent with the 8 inches. That's a very good question. I'll have to look into that a little more, Travis.
I got a quick point, a challenge for Nathan Oakley. I typed it in the chat. I have thrown it to him 2 times in 2 premieres. He have been active in the chat.
Drama.
And
Don't
he totally
drama.
No, it's not a drama. It's a challenge. It's a challenge to Nathan, because he keep ignoring me. This way, I know he listened to me also. He's not just reading and over-reading what I say. So I challenged Nathan Oakley 3 points. Present an evidence of Earth. You can call it a visual illustration or a model. It can be a crayon drawing. Just show me the shape of the Earth in a visual. Number 2, a calculator with predictive capability, how things disappear from the bottom up. And number 3, footage or pictures taken by yourself, evidencing the shape of the Earth, curved or flat. Thank you. I'm done.
Well, thanks for asserting yourself there, Jose.
Pushing yourself on us.
I say good day.
I bid you good day, sir.
Jose, he just forgot to say boom, Jose. That's all.
Yeah. Well, that's because it was
boom.
No, it's too late now. No, you had absolutely no pop there.
Yeah, he missed the curve on
that one. Okay, who's presenting? What the hell is going on in my show right now?
This is that maths, I think.
Okay.
This is the actual.
Oh, I see. Okay.
To show that would just be 1 degree off, and then I've just placed another one there.
Okay, so right now we're at 2 hours 40 minutes, which is phantasmal. I mean, it's actually absolutely phantasmic. I appreciate all you guys being here, being a part of this. So is everybody okay to hang out for a little bit longer? I have a special close that none of you know about, but you all have to participate in, so no one can sign out until it's over with. So let me know what the time constraints are. I'm going to say for me, because I have an appointment in an hour and 20 minutes, I would probably say 20 minutes is the limit for me for the rest of this show.
Same.
Yeah.
Okay?
Yeah, 20 more minutes.
Okay.
That works. 20 minutes is good.
Okay.
But you've built this up, so I'm looking forward to it. I'm excited.
Yeah. Oh no, it's gonna be fantastic. So 15 minutes, we're gonna round up, and I'm gonna totally bite off of Jose, and we're gonna have closing remarks and all that kind of good stuff, because Jose's got a fantastic show. I am so jealous, Jose. I know you've seen me say this before, but I'm gonna say it right now. I said this like a year ago to Chocolate. I'm like, dude, bro, we gotta break away from Nathan Oakley, bro, because dude, we can't get a word in edgewise, man. And I knew that there was another channel out there. I knew there was another opportunity, but I was on the road as a trucker and I had no opportunity. And you stepped into it, man, and you found the pocket, you found the sweet spot, and you've got it, and your channel is fantastic, and I love it. So thanks so much for that. But all of that to say, all right, so wherever we're at right now, let's keep going. Who just joined? Somebody just joined. Is that you, Derek?
Yeah, that's me. I'm back for a minute.
Okay. All right. Thanks, Derek. Okay. So anybody else? Otherwise, I could possibly delve into a file and we could look at some shenanigans on my file record. But unless anybody else wants to say something, let's go for it.
Well, Gleem was going to show something on his map, which was interesting.
Okay.
I think because it is quite interesting to know the 24901 getting the 69 mile per 1 degree, starting from a position where the Polaris is already at 23.5 degrees and working your way back that way. It seems to speed up quicker when you're using degree in correlation to the 8-inch. Like it wouldn't. Yeah, they don't match.
They miss a line. Yeah, they miss a line.
Yeah.
And the Globers would say that on anything over, I think it's only up to 1,000 miles or something like that, or maybe 400. That 8 inches per square mile actually works. But
Yeah,
then beyond that,
and I've got tons of them recorded, just inconsistency, whether admitting it doesn't work and then not offering an exchange, and then admitting it works at certain distances, and that's inconsistent all over the place. So
yeah, that's it. I'm sure someone worked it out one time and they done it over a vast distance, like 2,000-3,000, and it worked out at such a minuscule difference on doing it from 8 inches per square mile versus the real way, the long form.
I looked at the long form. You see, the thing is that obviously it would take me a while to figure all the steps of that long form. I looked at the formula Wikipedia. They break it down for you, and then they just say the derivative is the 8 inch per mile square, basically.
Yeah.
They'll go through all the rigmarole and show you the elongated formula, but then say the derivative is 8 inch closest anyway, approximately.
That's it. It's sort of like 7.9988 something.
Yeah,
So it works out to me. It's just like, okay.
Exactly. So if all your school books claim boats over curvature and all claim this is the result, then why does it fail so easily?
Yeah, that's it. Exactly that. Unless you get superlumin, obviously you superlumin, the rumpus tool.
Yeah, I do have a question for you, Gleem, regarding politically. Do you think the heliocentric model or the flat Earth model is actually a political party? Both ends, one's to control, maybe one's to divide. But do you think that there's a potential that flat Earth itself is a tool to basically divide and conquer the nation?
No, I think it's a division and a necessitative split of creation versus accident.
Do you possibly think that they're doing this as an intentional release to educate artificial intelligence for the next level of world truth?
I think that is more of a tool in their kit. That is one of the tools, similar to climate change and stuff.
Do you agree that flat Earth would be the ultimate of all conspiracies?
It would be the overarching one, the umbrella, of course, the dome one.
And do you think it's a slow release by any chance, or do you think it's like maybe divine intervention?
I think it's it coming from someone who believes in creation. It's many are called, but few are chosen. And then coming from a globe earthers point of view, it's more of a where we've got to today with openness, if you know what I mean. So our minds are so open nowadays that there's people that believe that the earth is flat, that disbelief. So I don't know, I think we're just all stupid humans, to be honest, and we could make mistakes. It could be whatever, we just don't know. We've all got ideas, we've all got
So let me jump in real
theories.
quick. When you said it could be, how did you say it? Something or whatever. It could be. How did you say it, Gleem?
Well, my true belief, I call myself a Mac Earther. My true belief is that no one can falsify either model, because both models have been built from the same observed reality. There is falsifications of it or evidence against and for either model, but you can't say with absolute certainty to anybody that, yeah, it's definitely that. And even the globe earthers can't say, yeah, it's definitely a globe, when they've got 20% of them believing in this many worlds theory, where it's a hologram of 2D or something like that. So we don't know. Nobody knows for sure. That word no.
Do you think if we approach flat Earth as a political partisan issue, in other words, we prove that there is a political party putting forth a globe, like a heliocentric model, because you can't prove it. There's no theory for it. It's like you said, it's unfalsifiable. You could prove that to be a political issue and a partisan claim, and therefore take it to court. Would you agree that would be a possibility?
Would be, but I just think it's a cycle. I think we're on a normal cycle of human beings. Like if you reverse it back in the Greek days, I bet globe earthers were laughed at and taken the mick at, exactly like we people are today.
Are you familiar with the post New World Truth that they had at the Bilderberg meeting in 2014 or 15? I think it was a big group of, maybe it was even around Trump's election or before then. But there was a big, world leaders got together, and they had 11 discussions. There's 11 categories of discussions. The last, or maybe there's more than that, but I think maybe one of the 11th categories, was post New World Truth. What do you think that means, being that United Nations has a flat Earth map, and they're in control of migration, child trafficking? They're basically, to me, from my research, the entity that could possibly be in control of pushing an agenda to disable regular education, banking system, like basically open the levee. And I'm kind of just hypothesizing at this moment.
I think that's their purpose. That's what it was set up for. If you can imagine, back in the days before government and whatnot, and that was way back before Egyptians, isn't it? So if you can imagine, before that, before governing people, it was just unruly, and then a select few have said, no, wait there, we're gonna employ this law. Everybody must live by our law, whether it's God or whatever. And it's more, the government is there to steer you down this path, to educate you this particular way, to make you, and from a conspiracy point of view, to make you a lumbering robot.
Can I jump in real quickly?
Yep.
Let me honestly ask you, when you say that before the Egyptians it was unruly, how are you able to say that?
I'm not. I'm working off of the concept of before civilized people, let's
Okay.
say.
That's fine. I
And
just was
and
curious. Okay.
and that
What
does
they tell
go.
us we're civilized people
Yeah,
because
Yeah,
some of the
exactly.
evidence points out that they were much more advanced than we were.
definitely,
That's
definitely.
my
No,
thought too.
I get that, and again, recording of data as well. We haven't got any of that from the Greeks, let alone all we've got is the inscriptions, hieroglyphics, and whatnot for Egyptians, and we still can't even get that right. We still don't even know what the pyramids are and whatnot. But I do fully get that, and I do fully support that, and I'm fully aware of the Bilderberg. I'm fully aware of the Rothschild backbone.
Sorry to interject. Wouldn't it be in man's best interest to allude that they don't know what the pyramids are? Wouldn't it be man's, like, what I mean is to keep the mystery going? Obviously, in my opinion, they know.
Yeah.
My opinion is they know the earth is flat. That's why they put forth the agenda. My theory is they know God exists. That's why they kill God. My theory exists is that we're stronger as a family, so they divide the family. My theory is that they need educated people, but just only educated enough to know how to push the button, just don't know how the button works. So that's what I think is coming to a head. And it's interesting to hear your side of it, Gleem. So much appreciated. Thanks, man.
No, salute. And I do see that there is conspiracy there. And I followed the 9/11. I was actually in the Royal Navy base when 9/11 actually happened, and we got all red Amber Alert and whatnot. So I fully looked into it, and Building 7 right the way through, and Richard D. Hall's breakdown, everything. And I do see it from both sides, but I do think that the government are capable and are designed to control people. That's literally the job is to make sure keep the people under manner.
And that's what the words mean. Government, governing the mind.
Govern your mind, yeah, or mindset, and it's the mindset of exactly that. I like to call it the flock mock paradox, and it operates both directions, because I see it, and as you said earlier on Nathan's debates, there's thousands obviously, but on Nathan's debates, you can get sometimes where there is one globe earther and they are getting a pummeling from multiple flat earthers. On the same hand, Jose's streams, you'll get one or two flat earthers in there getting pummeled, shouted at, called an idiot by globe earthers. It's identical on both sides. And I call it the flock mock paradox, where I say that if a flat earther went up to a globe earther and said, I can prove the earth is flat by measuring every square meter of the earth to be flat using a 1 meter ruler, then the globe earther would obviously respond, no, you're stupid. You're just using a meter ruler. You need something longer. And obviously he'd be laughed at. The flat earther would be laughed at for suggesting such a stupid thing of using such a small scale object. But then you look at it from a flat earther's point of view, and then a flat earther, or let's say a globe earther, always says, we know that Earth's a globe because gravity conforms and it all works. We can demonstrate it working. Gravity is a thing. 100% it's a globe. And then you say if you look into the failures of gravity on long distance tests, it absolutely drops off outside the solar system, which is outside the actual place it was designed to work. So it's been designed from that. It should work from that. But when you test it in the galaxy rotation curve problem and beyond, it absolutely falls apart. So then a flat earther has all the right to say, well, wait there. No, don't be stupid. Your gravity only works on a small scale, just like my 1 meter ruler. So you can't say that gravity is real. We've got to have a valid discussion, because your main mechanism.
Hold on,
That's
guys.
a good point.
Hold on, guys.
I have a question for you. 1 second, Travis, please. 1 second.
Okay.
Are you telling me that in 2019, heading to 2020, we don't have the technology to prove that boats don't pass over curvature at 3 miles? Are you telling me we don't have the technology to prove that claim is false?
It's not that you don't have a claim to prove that's false, but you present one picture or one bit of footage, one video.
No, that's not the question, Gleem. The question is,
yep.
Are you telling me in 2020 I don't have the capabilities or technology to prove that boats don't pass over curvature at 3 miles?
Okay, you have the technology to prove that to yourself. Yes. You do not have the technology to prove that to a globe earther.
So here's the way I would prove it to a globe earther. And tell me if it's a good way to prove it, because I have.
Let me jump in real quick, Flat Earth. Okay, so this point right here is going to close up the show, and then I have to close out with my spectacular closing that everybody has to participate in. You cannot leave. Go ahead.
With the hypothesis that it's an optical illusion and the angle of light produces an obstruction, I would first have an observer with a camera on the shore. Then I would have a drone midway point to 2.5 miles and have the 4-foot boat sit in a position of 5 to 6 miles with a helicopter flying above it, proving there is no physical curvature at 3 miles distance, concluding it's an optical illusion based on the angle of incident. Gleem, would I be correct?
That would be a nice reinforced double triple up, basically. Yeah, I like the idea. I like the idea. Whether you will convince someone with a religious view.
What I'm proving is there is no curvature at short distances of 3, 4, 5, 6 miles. I'm proving that a 4-foot boat will not be obstructed. In reality, it's only obstructed because it's an optical illusion due to your eye. That's it.
I mean, I follow that 100%. I would love to see their answer to that being presented, but that's exactly it.
We've already proven. We've proven
data,
6
data.
miles.
I know. I mean, all these, the Monterey Bay mirror.
It's not the point of 6 miles. You have to understand they're claiming it at such short distances, right? And they're using 8-inch per mile square. So that's the focus. Okay. That's why they want to obfuscate the 8-inch, right? So you have to prove it's optical using their math. And that's one way you do it. The smaller scale is the way to prove their math fails, because the angles of light don't bend in reality like they think it does. When you use angles of light, you can prove it's all optical. It's very easy to do. It just took us, well, it took me 4 years, so it's not easy to do, but it took me 4 years to learn the math and do the observations to conclude from the diffraction experiments or the double split that light acts that way. Light can actually obscure things, which is awesome.
Yeah, that's it. That's it.
Oh no.
Are we gonna sing?
Oh.
Up for it. I don't know none of your country tunes though. Ah, well, either way. Well, let's see what you got. I should have held my breath. There.
Hey, just for Travis, just so you know, the double split experiment, when you have the high troughs and low troughs, waves actually like kind of hit each other, and then they do something that makes an obstruction. So I don't know. They do something, man. They do something fantastic.
That's cute. Okay, you sing all the time. But you have that beautiful angelic voice.
La.
Me. You gotta put the lyrics up because I don't know him.
I read the news today. Oh boy, about a lucky man who made the grade. Although the news was very sad.
Just wanted to play a little ditty, bro. Sorry for interrupting.
Plain truth.
Who was doing the beatbox?
Young man. Young man. Need to be a happy young man. Young man. You know it's not the best. Stay there.
It's a bit weird. I prefer.
YMCA.
You can stay there.
Young man. Young man. Young man. Got to know this one thing. No man. Young man.
This is bad, Travis. You have to have you have to have the beat going, at least the melody, you know, so we can chime in.
Go, Jose. We're recording this.
No music.
Oh, say, it's fun to stay at the YMCA. It's fun to stay at the YMCA.
Right on, Jose.
Well, the lyrics are like
It
10
better not
seconds behind.
Thank you very much. Thank you very much. So I try to keep it real, more real as possible, and I enjoy when new people come in and join the show, and I like it to be in the beginning of the show, so I can have a little chat, little questions and answers, and have a few minutes chat, and then we'll open the panel. When the new person jump in that haven't been on my panel, I like giving them a really good slack, and a first chance to be able to speak without being attacked or double down with people, and that, Travis. So yeah, I'll try to keep my mind open and being fair to everybody. Boom.
That's really cool.
Jose, I've got a question for you. Well, it's not more of a question. It's like I encouraged Nathan Oakley to go incognito to go to your show, so he doesn't get like barraged for showing up to be Nathan Oakley. He can come as somebody else.
No, he wouldn't. If he go to my show, I'm gonna white knight for him a little bit, because I know he's gonna be attacked, and that person who decide to attack him, talk over him, I'm gonna give him the same chance to speak, and let's speak and make points and address the questions and answers. It's gonna be just a fair, normal conversation. I wouldn't allow it to be a shit show and a shouting competition. I will never do that. Yeah.
Well, I just think the idea would be fun anyway, just to have him go and disguise himself and come in as a different character. I just thought it was entertaining, the idea. Just
that'd be cool.
Well, I said he should disguise his voice, of course. Well,
It's fascinating. I was just saying it's fascinating watching all this and doing all the observations.
Travis, really quick, we got to do a little special one day, just to sing and perform the "Hello, Darkness, My Old Friend." The one version that Roth wrote for us. Oh yeah, we'll do that.
Come talk with
Yeah,
you.
and I'm a bad singer. The accent come through, but I think I can beat you, Brian. I can beat you.
Yeah, all the ladies they're not going to be able to handle.
Yeah.
I don't think
Enrique Jose Zias.
about that anyway. No.
Yeah. Thank you, Travis. Thank you, Ice. Thank you, Data, Gleem, Derek,
Salute.
everybody. I appreciate you having me. Thank you.
Salute,
Likewise,
everyone.
likewise, absolutely.